We are live.
All right, good. All right, so this is the final night, so this is good. I'm sure you guys are like, sweet. I don't have to stay up until all hours of the night listening to these two dudes just pontificate about who the hell knows what. So this is so we won't be doing any coding today. JC and I will banter back and forth about best practices and stuff. You'll probably see one or both of us cry at some point after we fight about some point on a best practice, because there are no such things as best practices. It all is whatever you feel like doing at that time and whatever gets the job done quickest.
No,
But we'll
free thought is not allowed.
that is not allowed.
It's best practice, man.
Best practice,
Why,
right?
why are you doing that? Best practice.
Yes, right, exactly. um, and then we will, but I'm going to start tonight and go through something pretty quick. I'm going to talk about more enterprise-oriented deployment concepts, so advanced deployment. If you remember back on week 9, we did that entire deployment thing through GitLab, right? And I'd have to say, even in enterprise, your typical POCs and even MVPs, minimum viable products, you'll hear us talk a lot about MVPs, minimum viable products. I'm sure you guys do too, and work and stuff. It's a pretty common buzzword now, business word, I guess, business process word. Um, is You'll probably still end up doing it the way we showed you in week 9, because that's like you saw, it's relatively stable, it's relatively efficient, and it's going to scale for quite some time. You have to really do a lot to get something to not work on a CPU on a single server. Got to have some pretty heavy load. Just today we were dealing with something, but instead of like trying to re-architect the code or optimize it, I just paid $5 extra a month and upsized the infrastructure to get an extra CPU or an extra couple CPUs, and it fixed the problem. So I mean, it's really just a matter of how much you want to spend, and it'll scale for you. It's really more of an iterative optimization step after, to go further. However, there are some infrastructures like IoT systems where you kind of need to start as you mean to go. Not to say you can't still deploy on DigitalOcean and run it, or AWS or GCP, but you need to architect so that you can jump quickly if you need to. So that's what we'll talk about a little bit tonight. So, what did we do for the last 12 weeks, right? Um, well, we did an implementation of an IoT system connected to a vehicle, right? Our vehicle's up there. And then we did a bunch of front ends, right? We had a mobile app that was native, well, React Native, and we also did a web app, and it was served through an Nginx proxy. Who can see the inaccuracy here? What is actually wrong with this picture? Anyone see specifically? It has to do with this Nginx, and it has to do with this client up here. Anybody see it?
Nginx is not there.
What's that? It has to do with our front end. Our front end was actually not served through Nginx, right? It's proxied through, but it's actually served by Netlify servers, right? It's not actually served by Ubuntu. You remember that? Because we actually did the CI/CD totally separately with our front end. So there's a little bit of hand waving here. But then we go through Nginx, and then we go to the back end, right? And then we go to the front end, which is actually hosted on Netlify, right? And then we also have our broker. And it's all ported through this Nginx proxy and then exposed as a proxy to this API.fullstacksc.com, fullstack, MQTT and WS if we're using WebSockets, and just our fullstacksc.com, which we also actually proxy through Nginx, but it's deployed on Netlify. And then we use databases, right? MySQL and Mongo. We also used another one. What was the third database that we used?
Redis.
Redis, right, as a cache. So the cache would be kind of up here. I left that one out. The other thing that we did, what else did we do? We just did this last week. Anybody?
Pandas.
Deployment.
No, we did a machine learned model, right? We did a
Yeah.
microservice, prediction microservice. So that would be yet another that would sit here that the backend
Yeah.
would communicate with, right? So this is actually a simplified thing. This is more of a general architecture, but we also have a microservice sitting, and then Netlify is doing this. So it's more of a logical. So the question is, so we have this, but how does it actually scale, right? That's the big question. So imagine that this system gets to Facebook, Netflix, or Twitter level of load, right? How do those systems do it? Because there's for sure they're not running on one virtual machine, right? They're running on many virtual machines. So how does it actually do it? And it actually starts with with how we implement and how we architect initially. Yeah, Reef.
So we initially run the front end and back end on a Docker, a single Docker container, right?
In development, we did like
And then,
within Docker. Yep.
so then we had our embedded on our local system, and late a couple of weeks ago, on week 10, you made into a Docker too. So you put that embedded inside the Docker as well.
We actually took the embedded. We while we actually wrote our code in the container, kind of.
Yes,
We actually run it outside of it, right, for Sumo. However, in week 11, we actually put it inside as its own container, right?
separate container, not a, okay. Yeah, I get
We wanted to run it in the cloud as a simulation.
Okay,
Yep.
so right now, how many? So we have three containers for the SQL, right? Three different containers for the SQL, and one
Oh,
container.
we actually have. How many do we have? We have six. So we have a broker container,
Yeah,
right? We have a backend container. That's our cloud. We have a front end container, but it's on Netlify, so we don't have to build that ourselves. We have a MySQL container. We have a Mongo container, right? We have a Redis container. So it's at six, and then we didn't actually do it, but I assigned that as kind of homework, and that is to Dockerize our prediction service, right?
okay.
So that would be our seventh container. Was not a container, although you could still put it in a container, but then you have to do your Docker Compose appropriately. Nginx we just installed directly on the server, but typically you would put that in also a container.
Okay.
You can. It actually complicates things a lot, and it's a little less flexible, which is why we actually like to install it on the server. It's very easy to install on the server and manage. Um, Typically, we'll do that, but there are reasons if you want to put that in a container. You know, portability, security could be one of them, maybe. Um, that's a, I don't know.
So when you say the Docker container, everything on a single virtual machine or multiple virtual machines. So it's one virtual
So
machine.
yeah, so for us, it's all on one virtual machine, right? It's
Okay.
because it's just Docker. But then when you go to scale,
Yeah.
the way we've architected is you can actually, what we say, scale horizontally. And we'll talk about that later. We'll talk about that in a few. So when we talk about scaling, what are we concerned about? Well, the challenges are first one is resiliency. So what happens when our VMs fail? And they do fail. Unexplained failures. Thing like the VMs go down. You have no reason why. You'll never be able to explain it. Who knows? Because one, chances are you're not operating your own hardware, and if you do operate your own hardware, Clayton, then you know how frustrating it would be, and you probably do know why it failed. Power supply failed, motherboard failed, hard drive failed, something along those lines. Well, that's bad, right? So you're probably pushing it up to the cloud. In fact, everyone is. Named Clayton, I called you out there, but you're now pushing stuff up to the cloud too. So that's pretty much everyone is. Um, but that means you don't control that, right? And you have no visibility into what their infrastructure looks like unless you're signing massive enterprise contracts and getting dedicated infrastructure. But that's on those deals are on the order of millions, just massive kinds of implementations. You got to be probably one of the top 50 companies to get any kind of traction like that with some of the big cloud providers. So what we need to be concerned about is because we have no visibility into the infrastructure, how do we get resiliency, and how do we plan for that when bad stuff happens, because it does. Delivery quality of service. So how do we actually guarantee that the same speed or at least data is available in our region, meaning West, East, Central time zone, as it does in Australia? Because I'll tell you, Australia is a pretty far ways away, and that latency is on the minimum 3 to 4 seconds from like even the West Coast, because it's either going under the ocean through the Pacific line or it's hitting satellites, which is painfully slow. So we really don't have an effective way. And so what you need to do is you need to figure out how to get data in both regions and keep that stuff up to synced up. We'll talk a little bit about that. And then consistent deployment, right? How do you orchestrate all your infrastructure so it's all reproducible and consistent? And that goes, of course, feeds into QoS and resiliency, right? Because the more consistent your deployment is, the more resilient your systems are going to be and how you can recover faster, right? Because you have a really nice deployment phase. In fact, a lot of times, Justin and I'll be standing around some on our big IoT platform. We won't know what went wrong. You know, something, or we get a flag. We don't know what went wrong. So Justin goes in and says redeploy, and it'll just redeploy, fixes it. Okay, cool. Like, if it happens too many times in a row, okay, then we'll look into it. But sometimes it's just something happened. It's okay. We'll just redeploy, and it fixes the problem. But with click of a button, we can do that because we have a really good orchestration for deployment. And then, of course, security. How do you maintain that through the entire stack? And I mean, there's entire teams that deal with that on large systems. But it really starts with the architect because security comes from a good architecture. It's really easy to secure a good architecture. It's impossible to secure a bad architecture. That's it. Really starts with the architect and the developers, and that's one of my big things. As an architect, needs to be well versed in security. And so many times you find architects who just really have no clue about security. And so we haven't gone down deep, really deep in security over this, but I'll tell you that security, a lot of times you hear people talk about security and they'll say, oh, I got to get the certification here and I got to know all this about cryptography and everything. No, that's not security. That's not security. What security is just thinking like a hacker would. So if I was trying to attack this system, if I was trying to make this system do something that we wasn't supposed to do, how would I do that? And you understand, as the architect, you'll understand the best of what could happen, right? So keep those things in mind as constantly as you're walking through this. You're just always thinking, how could someone thwart this? How could someone expose this, right? And it's just constant thinking about that. It's rarely like, oh, I wonder what cryptographic scheme I should use or encryption or whatever. No, it's really comes down to the worst security holes are the ones that are just an obvious omission of either not understanding or just forgetfulness on an architect or a developer's part. But then you also, as an architect, have to of course, goes to the developers and just push that down through to the developers, constantly harping on them. Justin probably is constantly, saying, rolling his eyes because I'm just harping on it. Clayton, I know, is rolls his eyes. Like, yeah, he's just harping on the security thing over and over. Shut up about SSL certificates. Shut up about them. But it's just I just constantly remind because we forget those things. Even the best developers will forget.
I mean, it is funny, like these days, how many websites don't have SSL certificates still, given the fact that there are free services for them.
It really is. It is unreal. But it's laziness or it's not understanding or it's just, hey, I haven't touched that system in 2 years, it's still running and no one's complained yet, and who cares? But it's that's probably what it's more apathy than anything, unfortunately, and it shouldn't be. But or they may say, well, who cares about that data that's not encrypted? Who cares? Well, that's not the point. The point is privacy, right? So anyways, there are so many tools out there, and we're not going to go through every single one of these icons. There are a ton of icons, and there are more. All right, there's an infinite number, endless number of icons and products. Most open source. Most of these on here are probably open source. In fact, I don't see any closed source on here, amazingly, other than maybe some of the Microsoft technologies.
Web services.
Oracle, yeah. IBM, if IBM's on there. But a lot of the other ones are all open source. But yeah, so anyways, they're just all over the place, right? Just amazing amounts of them. And so,
Right.
like, let's see if we can. Does
Mhm.
someone have a question?
Yeah, I had a quick question about SSL.
Okay.
When you see a site which is secured with SSL, it does not necessarily mean the business is genuine, right? It's only the site is secured, right? I mean, I'm
Right.
trying.
Correct. Yeah. There's in fact, Let's Encrypt allows anybody to create
Yeah.
certificates, and but in my days when I was maybe a little less on the up and up, I would, of course, I was always doing it for the betterment of people. At least I like to tell myself that. Um, was that I would create fake sites, right, in order to drive people and people and business dealings, right, to other places, and I would just use Let's Encrypt or another SSL certificate. It doesn't mean that they're legitimate in any way, shape, or
Right.
form. It just means someone either paid for the SSL certificate back in the day, or as of like 2017, they just use Let's Encrypt. Um, there's very little that you can tell from the certificate. You can go and check out the certificate. So, like here, you can say connection secure, but I'd like to know more about the actual certificate. You can click on it. This is GitLab, right? Um,
Mhm.
and you could see that it's set to go. I don't know. User trust. I know that that's a CA. I don't know much about it. Obviously, one of the trusted ones in the browser. But if it wasn't a trusted certificate authority, then the browser wouldn't accept it. So you would know. It would say it's not secure or something. But it's so easy to get it that now, obviously, we're trusting GitLab. Yes, of course, right? I mean, GitLab's a pretty major service, but um, even one of ours, we'll show you later tonight, IOTRY. This is our. Ooh, interesting. This is our IoT service, managed IoT service. But the our certificate is actually done by Cloudflare because we actually proxy through Cloudflare. You remember Cloudflare from week 9, where we actually did the DNS management. So Cloudflare actually fronts an SSL certificate, but we also generate SSL certificates between Cloudflare and our load balancers, which are our Nginx proxies and load balancers. And so there's SSL chains every step of the way. So oftentimes, and you saw Cloudflare's Flurry, so anyone can sign up proxy through Cloudflare. I mean, who knows, right? So it's just one of those things that um, it does not particularly dictate whether or not a business or a site is legitimate. Just someone went through the effort, sometimes not even any effort, to generate an SSL certificate for it.
Right. Thanks.
So, can we narrow down some of these tools? I guess kind of. So we'll try here. So DevOps, right? This is mostly week 9 stuff because we're just doing advanced deployment. DevOps, right? Developer operations. That's the big thing. And honestly, what I would say, if you don't like to code, you should probably gravitate towards because it's more configuration, as you saw, right? Week 9, we did very little coding. The only coding we did was change some variables, right, in terms of where things pointed. So this is all configuration. All these tools that are up here is all configuration stuff. So like infrastructure as a code. Um, so basically, you could claim that these things kind of are recipes for DevOps for deployments, and so you can do those. These are kind of old now. I wouldn't say old. A lot of people still use them. These are very popular ones, so you'll still see using them. A lot of new systems don't use these unless you're used to these tools. A lot of it's just if it has a following and if you are comfortable with them. I'm not going to say one is better than the other because it's not, right? It's just whatever you're comfortable with and whatever gets the job done. Um, like a Chef and Puppet are very popular ones, and I've used both. They're both pretty good. They're basically infrastructure that allows for pretty good DevOps stuff. CI/CD, continuous integration, continuous deployment. We actually use GitLab for this. I did not put GitLab in here, although it could easily go. And GitHub even has actions now, released as of what 2 weeks ago. So but Jenkins is probably one of the oldest, most popular ones that you'll see a lot. In fact, most enterprise stuff you'll see Jenkins. A lot of people still use Jenkins, very popular. And what it is basically just a runner. It's a deployment runner. And so you can script little steps, right? Build steps. And you just put a little configuration script in there, and it's like, hey, build this code, build this Docker container, deploy it here, SSH in here, you know, and npm install this, things like that, right? Stuff that Docker's doing for us, but there, and then Bamboo is an Atlassian product. I have a severe allergic reaction to anything Atlassian, but that's just me. Jira, if any of you have used Jira, I cannot stand it, but I'm sure some of you have had to use Jira before, but it's awful. And then you have test automation. Appium is a very popular one that I've used before. It's test automation is like Mocha, right? Where you can use basically your CI/CD, your Jenkins to kick off Appium, which will run all your Mocha tests or something along those lines, and then give you an output whether or not it's valid or not. And then you have your containers, which are then deployed, right? We all know about containers. Docker's the biggest one. There's probably about 12 more that are quasi-relevant, I'll say. I mean, they're really not anymore. I mean, Docker's pretty much the de facto standard. You'll see a little bit of another one called LXE. It's very, very tiny containers, used a lot in embedded stuff. But it's a lot older, and I don't know how well supported it is anymore, but I do see still a lot of community stuff around LXE. Then you have orchestration. Orchestration is how do I actually get all my containers and they run, so that now we're getting more into runtime, right? And so Kubernetes, which we'll talk about a lot here, is a very, very popular one. We use a lot of Kubernetes. It's very, very difficult to get, but once it goes, man, it's awesome. It's really good, and you can use other tools like Helm and things to configure it. And then a Docker Swarm, although Docker Swarm is really going on the outs now. You don't see a lot of Docker Swarm now as of probably about 5 months ago, but it's here because some people use it. In fact, we still use Docker Swarm just because we used it for one of our health QRS. Docker Swarm is basically container orchestration for Docker. It's Docker's product for that. Then of course you have deployments. Elastic Beanstalk is AWS's product. It's kind of like a CI/CD, but deployment's more about making sure things are deployed effectively and consistently. So once again, templating, things like that. Then you have measurement, right? All your logs and everything as they go. And reporting and notifications and things when things are not going the way you think they should be going and stuff. And then of course you have chat ops. I put that over here because, well, it's one of those things that is always supposed to be here, but it never quite reaches. That's the next thing, right? Where you can actually just chat with all your infrastructure, and it just works and chats back and all that crap, right? So let's talk about what we actually use out of all that crap. We use platform as a service for our infrastructure. So GCP, AWS, and Azure, and DigitalOcean. And then once we go really big production, we'll graduate to the big boys, these three. Our container technologies, Docker, completely. CI/CD, I used to use a bunch of Jenkins. Now we are almost all GitLab. I did some GitHub Actions today just to see how they are. I still like GitLab better. And then Azure pipelines, having to do some of that because a lot of our enterprise clients are wanting Azure, Microsoft product. So there's that, and then orchestration, like I mentioned, Kubernetes and Docker Swarm. We do a lot of those things. So how do they all fit together? Now we saw this in week 9. We actually went through it, right? This is another example, and it's not using GitLab. Instead, it's using Google Cloud Platform, GCP. Of the three platforms, I still like Google Cloud Platform the best, and I've done probably equal systems on all of them. In fact, one of our enterprise clients, we started on Amazon. This was 6 years ago now. Started on Amazon. Year and a half later, drank the Google Kool-Aid. We had to migrate to Google. Did it in a few months. And then as of last year, they drank the Microsoft Kool-Aid, and now we're on Azure. So I built a platform, and the same platform has been on all three clouds in the matter of a span of like 4 years. So we can talk pretty well. GCP is still my favorite. It really is, and I'll show you kind of why when we look at them. But here's an example of GCP. Using GCP as kind of a build, and what you'd find kind of in an enterprise sort of thing. So developers down here, right? He's got his coffee that's fueling him, and then he branches and merges code, right, up to GitLab. And GitLab basically has a GitLab hook. So you can set up GitLab hooks. In fact, let's look at this. Let me see. Do I have one? No, we'll just do it here. So there's in settings, you can go to integrations, and in these integrations, you'll notice they have all of these built-in hooks, integration points. And what you can do is like Drone CI is another continuous integration thing. I didn't even, another one. There's a let's see, there's a Jira, right? Atlassian Jira trackers. So you can say, hey, if a branch or an issue is created in GitLab, automatically created in Jira. Microsoft Teams notifications, so you can push a note to Teams, and then Slack notification. In fact, we have tons of Slack channels on some of our different Slack workspaces that get really freaking annoying really fast because we'll actually have all of our applications slacking us to tell us, if they're alive, or if when rest routes happen, or all that kind of stuff. And you usually do it for about 2 days, and then you mute the channel because it gets too much. And then you start selecting other channels like failure channels and things that only notify you if something's wrong, kind of stuff. Anyways, you can see all of these different things, and then you can also do custom webhooks that will you can say, hey, just hit a route and hit a route in my infrastructure if something happens. So what you'll do is you'll set up one of these integrations, and specifically a Jenkins integration, which will just accept a webhook. And Jenkins actually will have a GitLab sort of integration point, which it'll spin up a little route, a little REST route that GitLab will hit it, and then that'll kick off a build. And what this build is, it configures it, it pulls the code from GitLab then using all those SSH keys and everything we talked about, like the deployed keys and everything, same thing that we did in week 9. And then it builds and generates a Docker containers through Docker Compose or whatever. It'll push those Docker containers up to a registry, a container registry. That's something we did not do, right? We skipped that step. Instead what we did was we actually built them directly on the server we were running on. Well, typically what you want to do is you actually want to push those containers up to a registry. And you're doing that for reasons of scale. We'll talk about why we do that. And then they get deployed to either a virtual machine. In this case, I'm using Kubernetes. And Kubernetes is an orchestration, so it runs all its containers. Some of the advantages of Kubernetes are the ability to do auto failover. It'll actually boot up multiple instances of your app, and it'll handle load. So if it detects that there's high load, it'll scale up multiple containers in your app and load balance appropriately. It will also do auto load, auto reload, which means that you will never ever have any downtime. So it'll make sure that one container stays up while the others are rebooting, and then finally take it down and then switch it over immediately to the new update containers. There's lots of really cool stuff that Kubernetes kind of does under the hood for you that you'd have to build a bunch of infrastructure to manage anyways, plus a number of other things. And then all of this is deployed and run on Google Cloud Platform, on GCP infrastructure, whether that's, they have a managed Kubernetes service. We'll show you that in a few. Or you can do it on a VM. We did it on DigitalOcean. You do virtual machines on their compute nodes, or EC2 if you're on AWS. And then all this stuff just serves up right through a load balancer. So that's kind of another example of more of an advanced deployment. Really, it comes down to this container registry, and kind of why you do that is so that you can pull multiple. If you have multiple servers, multiple VMs, and multiple pods in your Kubernetes that are running, what you're going to want to do is you're going to want to grab multiple containers, right? And so you actually want one place to be able to grab all those containers from. And that registry is just a holding place, right, for all of that stuff. and that's why we use that there. So continuous integration, continuous deployment, CI/CD. We did this on week 9, but this is a Jenkins dashboard. If you guys are interested in what that kind of looks like, it looks very 1990s, late 90s, early 2000s. They haven't updated it, but people still use it. Probably doesn't need to be updated. It kind of gets the job done. But you run tasks, right? And so you can see that it installed this specific one is installing SSL packages, SSL certificates, and then doing a few other things. Checking to see if pip is installed, right, for Python. Seems to be doing a Python app. And then you could just configure all that stuff, and it can be kicked off with a git merge. This is the GCR, the Google Container Registry. All the different cloud providers have container registries, including Docker Hub. When we pulled MySQL and Redis containers, that's a Docker registry. We pulled them from a Docker registry. It's just Docker Hub's container registry. And so if you wanted to, GitLab also has a container registry. In fact, you can see package and registries. There's a container registry right here, and it'll even tell you how to do it. You can log in, and then you can build your image, and then you can push it. In fact, you guys are used to this. We did this in week 3 or 4. JC actually built a container. He pushed it to a GitLab registry, and then you guys pulled it down. Remember when we were having those issues with Ubuntu broke? Well, he actually built it, pushed it on the registry, and then you guys used that one. So you actually already have experience with that, but we were using GitLab's container registry. So if you wanted to build, instead of GitLab registry.gitlab.com, it's us.gcr.io. That's Google Container Registry.io, and then you can push it, and then it's on there. All the credentials have to be worked out. So a note about Kubernetes. I've been talking a lot about Kubernetes, but haven't really gotten into like what it is. And we could go on. We could do an entire 4 hours on Kubernetes. It's very, very complex, but it's a really nicely put together system. But really, it's ops orchestration, and its primary function is to really manage health, right, of your deployed system, and to scale. And there's concepts of nodes, pods, and service and deployments. So a node is run, and that's basically the process that's run. And then you have pods, and pods will run multiple nodes. And so you could have, actually it's the other way around, sorry. You nodes, and then you have pods. And what happens is these things are run. It looks serverless. You'll hear buzzwords called serverless, right? It doesn't. Everything, there's still a server and everything. It's just maybe you don't see the server. Kubernetes is kind of a serverless thing where these pods and nodes, they're actually run on multiple virtual machines. So Kubernetes tends to be a lot more expensive because instead of booting up one VM like we did for our week 9, Kubernetes will actually boot up 3. And the reason they boot up 3 is for resiliency. So that's one way that they get around the resiliency issue is we'll just say, well, we'll boot up 3. We're going to we're going to run equal things, equal deployments on all these, and then we'll just make sure that if I'm detecting that one's down, I'll just switch to the other one, and I'll make sure that that route never gets lost in the process. And so that's really what it is about, health and scaling. The other thing Kubernetes will do, I mentioned before, is it will actually boot up multiple pods and multiple nodes, auto scale, what we call auto scale. So if it detects a high load, it will automatically scale, and then it'll automatically scale back and shut the stuff down you don't need. So it technically is a cost saving in that way. And then you can set limits and things like that. Say, hey, never go beyond this because I don't want to spend this, or all this kind of stuff. So there's lots of stuff. If you want, I would highly suggest, if you're interested in this stuff, going to kubernetes.io and look for Minikube. Minikube is kind of the test infrastructure that you can download and install on your local machine. And in fact, if you run Docker Desktop, you can even say start Kubernetes. And Docker Desktop ships with Kubernetes, as it turns out. In fact, I'm not even running Docker. I shut it down to make sure there wasn't stuff. But if you look, there's a little Kubernetes thing that you can run.
Jesse, Kubernetes, BJ, Kubernetes are not open source, so we need to pay for it? Or?
It's totally open source, everything about it.
But it
It was
opens
built.
up multiple virtual machines. So you said it opens up multiple virtual machines, right?
Well, it's open source, but yeah, you would have to actually run it on hardware that you pay for.
Oh, I see. I got you.
Yeah, I mean, it's at some point you're paying for something, right? You can run Kubernetes on your own. You could boot up, like my three machine learning machines right here, right? You could boot them all up and run them on that if you want. Wouldn't suggest that, but you could if you want. But then you're just paying for electricity, so you choose, right?
So,
All right. So there are some things that I will warn you about Kubernetes, which gets a lot of people. Um, Following the samples and stuff are really good with Kubernetes. You can get somewhere fast with them as long as you understand your service and deployment configurations. Connecting to databases is a whole nother thing though with Kubernetes. And the most of the reason is because of how they scale. Databases, as you can imagine, they have the same load balancing issues as our apps. We just don't think about it in the same way, but you can imagine that if you have, let's say, 1 million containers, right, spun up, they're all the same cloud. Let's say we have a ton of vehicles, right? We're at like Twitter level load around, I don't know, America's Got Talent or something, right? And I mean, or Super Bowl, whatever it is, just massive load, right, on our servers. What you're also trying to communicate with databases, right? So we're saying, okay, well, I'm not worried about my database. I'm just worried that I can handle all the connections coming in. But if you're scaled horizontally scaled thousands of your cloud, right, your back end, in order to handle all of these connections, well, your connections are also hitting your database. So your database also has to scale. So it's not like it's not like your database magically is impervious to these scale issues. And so what you end up having to do is you have to set up proxies to your databases, and you have to set up replica sets and those types of things. We don't go into those right now because that's a whole other area which we don't have time to go into. But just be aware that if you're seeing performance issues with Kubernetes or even in Docker, and you're like, man, this is scaled pretty high, always look at your database. Look at the number of connections your database is trying to manage. And if that is the case, then maybe consider load balancing your database and actually setting up replica sets where you actually will copy data back and forth. And oh, by the way, that's the same way we get data to Australia as we do into the United States and North America. So it's kind of the same type of strategy. You just set up replica sets, and then you load balance across them, and then you regionalize. So if your connection is coming from Australia, you make sure that it hits the Australian database path of least resistance, and then if you're coming from North America, you make sure you're hitting the North American regional stuff. So it's kind of the same stuff all over the place, regional as well as load balancing for proxying. It really comes into play when you're talking about Kubernetes, because by definition, Kubernetes is scaled first. And so if you don't proxy your databases, you're going to run into your scale issues with your databases sooner than you would like, much sooner than you would like. In fact, much sooner than if you just have them on a single DigitalOcean VM. It has to do with how the connections are managed and all of that kind of stuff. GCP actually forces you to do it from the get-go. It's actually really nice. They force you to go through that pain at first. They don't allow you to even connect directly to your database. AWS does not necessarily with their RDS. We'll talk about that. Azure definitely doesn't. And we just went through this whole thing with the big enterprise client probably a couple of weeks ago, that they couldn't figure out why there was performance issues. This was after they were maintaining it and we were doing something new. And they were like, man, we can't figure it out. It was working on GCP, but it's not working on Azure. Why is this? It's the same thing. And I looked immediately, I said, no, it's not the same thing because you didn't proxy your database connections. GCP already had that. And so they had to go through this whole thing with Azure to proxy their MySQL connections and everything. So it's definitely an interesting thing. So just be careful. All right, so let's get into a few things. I wanted to do some use cases here. So these are real systems that we've deployed over the last number of years on different systems. I'm going to show you GCP and AWS. And so GCP is Google Cloud Platform, AWS, Amazon Web Services. So this is a connected mobility application, and what we did here was we've deployed it, and here's our embedded device, and it also has apps and a web app and like a dealer network and all those kinds of things. And so it's load balanced, actually not through Nginx, but GCP provides globally regional load balancers already, which are probably run by Nginx, quite frankly. But they basically do it so you just configure them, and they'll do SSL termination and everything on all those load balancers. What those load balancers do is they make sure that that traffic goes into the appropriate, what we call VPC, virtual private cloud. So it's basically a firewall around all of your infrastructure. And you'll notice that there's only one gateway into it, is basically through your load balancer, which basically only has 2 ports open, right? Or preferably 1 port. And what port is that? Anybody?
443.
443. Yep, SSL, right? You may have a few others open for MQTT or something, but preferably you actually port that through 443 also, just by a different subdomain. And so you basically only have that 1 port open, which allows you to manage that a little better. You also have an entry point in here too, because the repos that we were using are actually hosted on GitLab, or GitHub, one or the other. But they're not inside of the infrastructure. If you need your repos, like if you're doing a healthcare application, which we do, if you need those things inside of the infrastructure, GCP, all of the big cloud providers also provide their own Git service. So you can either use that as the Git service, just like GitLab or GitHub, but sometimes you don't need to, because code does not necessarily fall underneath PHI if you don't store any PHI, personal health data and information inside of your code, which you shouldn't. And then what we do is we have a build server, Jenkins, here. And then that pushes to GCR, the Google Container Registry, which we talked about before. Then that deploys to Kubernetes, which is this. And you'll notice that we have an MQTT service. We have a device service, user service. You can probably see what the mobility service is there. And then other services. And then what it does is it gateways through all of this stuff. And these are all microservices. So a device service is a microservice that handles everything device oriented. So all the authentication, authorization, all the credentials, all the data, everything is by the device service, which actually uses Mongo to store all the device. At this point, we have, I think, about 50 terabytes of IoT data in this system at this point. It's been running for about 5 years. So we have a lot of IoT data on a number of different things all over the world. And so all of that's stored in MongoDB. The rest of the relational data is actually stored in MySQL, so you can see why we did it our way, right? This comes from learnings and things for real scaled IoT systems. And so we use Cloud SQL, which is a managed MySQL service by GCP. We'll see that in a few. And then we have 14, or well, I think it's like 20 now extra services that range from issue service to a dealer service to many manufacturer service that actually does automated manufacturing now, where a manufacturer can scan the device that they put onto the actual thing, and it automatically provisions itself and all that kind of cool stuff. And so all that's managed all through that. And then what happens is GitLab deploys, and then it goes back down through CI/CD to uses GKE. This is the Kubernetes service, GKE, and then it auto scales. We use Datadog for monitoring, which hooks into all the Kubernetes containers and basically sends all of the logging right where, and right now what we do is we print it out to a console, right? We just do print, console log or print, right? We just see those logs. Well, in deployment, that's not always the best thing, right? Because you can't always access those. It'd be nice if you had just an interface you could go to. And so one of those is Stackdriver. GCP calls their global monitoring service Stackdriver. It's a product. All these things cost. They're not open source, right? These are all like built products that you buy from these services. And that will be deployed. That's where Datadog will put things in a Stackdriver, and you can just have a nice little web interface to go and see all the logs from all your services and all that kind of stuff. And then Most of these are running on actual VMs. You can see that they're multi-region clusters. We have East Central, and now we have one in Australia, and we also have one in Eastern Europe to handle Russia and most of Europe. We also we have 6 nodes total per region, 6 pods each, so that's about 175 total um, processes that are running within this IoT system. So it's a pretty massive operation to keep this thing running day in and day out. Fortunately, it's pretty much hands off now. We basically just get to step away from it and get called every so often if there's an update or something that's a little bit more involved. But in the end, it's auto deployed, and it runs pretty smoothly. So here is the same application, but on AWS. If you remember what I said, that story, we actually went from AWS to GCP. So what we showed you was GCP, and then Azure similar. Can't show you Azure because now that's proprietary. I can show you these because, well, we're not on this anymore. So the AWS, and we probably should still be on the GCP one, but whatever. Well, not my decision, that was theirs. The AWS, we switched. So AWS started like this. You'll notice these are our repos. They were in GitLab. We did have a build server on Jenkins. We used ECR instead of GCR. ECR is Elastic Container Registry. That's AWS's product, container registry. We actually ran, at the time, there was not a managed Kubernetes. AKS did not exist. Or EKS did not exist. And so we basically had to run our own on AWS. And so we had scaled horizontal device service, user services, OEMs, and stuff like that. We had MySQL RDS, which is RDS is the relational data storage. That's AWS's managed MySQL service. MongoDB, we used a managed MongoDB. It still do actually on MLab. MLab's being sunset by December. It is now Atlas because Atlas bought MLab, but it's all pretty seamless. Atlas is great. You can go in and sign up for a free, like 512 megabytes worth of Mongo hosting, and they'll give you a URL and you can connect to it. You know, if you install Mongo, it's pretty nice. I really like MLab and what's now Atlas. And then we used ELB, Elastic Load Balancer, which is AWS's load balancers, like Nginx. And we also used Hot Proxy, which is another Nginx type thing. We use Hot Proxy actually because it had better, it still does have better TCP support as opposed to HTTP support. So you can proxy the MQTT TCP streams a little better. The SSL termination's a little bit nicer in that kind of stuff. So anyways, we also set up our own little load balancers for each one of our services. That's one thing Kubernetes does for you, is it actually does your own load balancing for you. We weren't able to use that, and so we had to set up our own load balancers for each one of our microservices for the gateway. So that's an AWS GCP example. And I want to show you another example that comes from some of my own research, as well as this is implemented. This is a machine learned thing for vehicles. Did it for a European auto company, and what this is a fully managed, scaled, operationalized machine learning system. And so what we did was we used an NVIDIA TX2. That's a very popular hardware platform for machine learning, computer vision. And what we do is we actually use Sumo for simulation, but we actually have vehicles on it now that would do in the loop, hardware in the loop simulation of the actual vehicle. So this is our embedded domain. And what it would do is it would actually send vehicle data and parameters. I was specifically interested in battery aging, actually. And so one of the things that we were looking at was putting up SOC, state of charge, and IVT, current voltage and temperature data, up into the cloud, into our managed IoT service, iOttery, and then we would webhook over to what we call a value-added system, and this is on GCP, Google Cloud Platform. And what would happen there is let's focus on so this right here is what I'm showing. So number 2 here, you'll notice. So this is the webhook over from our IoT data. So basically, it comes up iOttery basically, and I'll show you that in a little bit, just shoves the data back over to our value-added system. So our value-added systems are a gateway, our cloud, right? And so this data gets posted in a vehicle. Typically, it would happen at night. You'll get big data dumps because you don't flow data. It's coming off of like electric buses and stuff. So they'll come into the shop and then at night connect to Wi-Fi and dump their data, that kind of thing. What we do is we actually cache it in Redis. And then once it gets cached in Redis, we actually do input conditioning. And so that data is very noisy. Plus, we also have to verify if it's valid data. We talked about that a little bit last week. And then what we do is we actually store conditioned features into BigQuery. BigQuery is a really nice GCP relational data storage that's meant for terabyte size data. And so it's really, really effective at that. And then after we input condition the features, so these data, IVT, current voltage temperature come in, and some other stuff, they're conditioned for noise filtering, stuff like that. It's a little bit of signal processing, split out into features, and then the model is trained automatically. We actually leverage some GPUs. We use TensorFlow for that, stuff like that. And then the model parameters are actually deployed down to a REST API here, which is classification. And so we actually run a classification report on whether or not the data is verified. So we'll run metrics, statistical metrics and things to see, one, we'll do a test validation set. We'll make sure that the errors match up and everything. And then what we do is we actually package up the models parameters, which we then push back down into the TX2, this embedded domain, and then your machine learned models actually run on the embedded domain. So it's a pretty effective way. And then you can do stakeholder reporting and stuff with, I love Streamlit. Streamlit's a really nice thing. In line with Python, you can do graphing and actually some UI controls and stuff with like 2 or 3 lines of code. It's really cool. You're not going to win any design awards for it, but it sure is nice to do quickly if you're just worried about data science and getting some visualization on your data. And then Kubernetes is used for all of this to orchestrate this whole thing. It's all CI/CD. So that's some machine learned stuff in the wild for totally operationalized, and that's truly closed loop operationalized data, right? Because what we're doing is we're getting data, we're training on that data, automatically verifying it, and then pushing those models back down into the field to be used on embedded models. So you're actually training the models from crowdsourced data, pushing it down to the embedded. So now the embedded device, that vehicle now has all the knowledge of all the other vehicles too in its own trained models that it can then run. So it's a very interesting and well, it's cutting edge right now. We don't do that very much because of the risk associated with auto tuning and auto ML. So lots of good stuff there. So that's another kind of use case. Before we go into best practices and finish it up, I've been promising you guys that I would show you some of the management consoles and stuff. So I've been talking a lot about GCP. Let's start there. So this is Google Cloud Platform, console.googlecloud.google.com. You can sign up for free. It's a massive platform. These all are these platforms as services, but you'll notice that they've got my favorite ones pinned up here. So you'll notice my top, I guess my favorite one that Google has machine learned to know that I click on that the most, puts that at the top of my list for me. They have clusters, workloads, services and egress, applications. You can do all of these different things, object browsers. I don't think I have any running right now. Yeah, I'd have to create a cluster. But I guess I'll show you. I won't actually create one, but when to actually create a cluster, we can you can see here that you can name your cluster. You can do different regions: U.S. East, South America, West, Europe, Australia, Asia, lots of different places. You can do different versions and stuff, and it will automatically deploy it with just that configuration. So it's pure configuration, right? And then you basically define what your automation stuff is, and then what your network information is, and then any kind of security stuff you have, and then you can do TPUs, which are machine learning stuff, and then you can at that point then you define your service and deployment configs, and the service deployment configs tell and they look like Docker files or Docker Compose files. Actually, they're YAML, and you can specify what kinds of stuff you do, where your containers come from, where your Docker containers come from, stuff like that. So Kubernetes just runs Docker containers. Your VPC network, you can have firewall rules and things like that within your VPC. You can see some of mine here, so you can see where different ranges and different ports and stuff like that. You've got a number of other things like the administration for all the users. Your compute, they have an app engine, which is like a managed, once again, a more managed container service compute engine. That's like DigitalOcean's Droplets. This is the kind of the core virtual machine. So if you, I don't have any VMs running on this specific. I have a ton of different projects, but if you create a VM instance, they call that compute. So that's their product name. But you can see, just like in DigitalOcean, it looks similar, right? You can get different CPUs, all this kind of stuff. You can choose things from a template. You can do Ubuntu or Red Hat or any of that kind of stuff. Pretty standard stuff. Cloud functions, these are serverless, right? Where you basically will just write your code like a JavaScript or Node. It'll give you a little REST endpoint, and then it'll run that code as a REST endpoint automatically. I have a little hello world function here, I guess, in this specific project, and you can tell that it's got different triggers. It's just if you hit this URL, I guess, it will do something. So maybe yeah, no message defined, so it actually did something apparently. So anyways, you got all that. And then the thing that really starts to be really cool about GCP, that they've completely run away with it, in my opinion. You have tons of different storage options that go beyond just blob storage and things. But they have a lot of managed databases like BigQuery. They have SQL here. Memory store is Redis and Memcached, so they've managed Redis servers. Firestore is a nice NoSQL database, things like that. They have some networking, just standard networking, where if you're doing a lot of enterprise stuff where you might have to connect to on-premise infrastructure as well as other cloud infrastructure, they can orchestrate that for you. A lot of ops, so monitoring. We just talked about CI/CD. A lot of monitoring, logging, profiler. Stackdriver is going to be in there. And then these are all of their stuff. You have an API gateway, identity platforms, builds and tasks. So this would be, and then this is GCR, Google Container Registry that we talked about. And then you've got all the big data stuff. They even have a managed IoT service, Google IoT. Big queries here. They have a whole nother life science and healthcare. And then this is my favorite part, all of this stuff with AI. They have all of these managed machine learning pre-trained models for you, so you can just deploy these. They're expensive to run, but they're pre-trained, so they save you a ton of time, and they've already pre-trained it with a lot of data. So that's what makes this video intelligence. You can do auto ML on images. They already have pre-trained object detection, where you can do it, and for $3 you can, predict. You can identify tons and tons of like thousands of images. And then they also have the partner solutions. So GCP has a significant amount of good products. This is AWS, Amazon Web Services. You can see all of the different Amazon services here. A lot more than Google. Why? Well, because they've been around longer, right? AWS was one of the first. But CloudFormation is one of the templates. CloudFormation is one of the first kind of CI/CD deployment things where you can define your own templates, and then they'll set up. You basically set up your entire AWS infrastructure from a template, and it'll deploy EC2 instances, databases, and things, and that's CloudFormation. They'll also do, you'll hear a thing called CloudWatch is their monitoring. CloudTrail is also some monitoring stuff. Code deploy or code build and code pipeline are their continuous integration, continuous delivery products that are a lot like GitLab CI/CD that we used. They also have EC2. EC2 is their elastic compute, and so that's their VMs. So I don't have any running in this specific account, but you can set up your own EC2 instance just like a droplet. It's analogous. In fact, I have a couple, but they're stopped right now. And then there's a few other services. They released Ground Station. That's cool. So they have a satellite thing. And then Amazon Redshift is a big database, NoSQL database. And then another one is RDS. RDS is their managed relational database service, and that is like MySQL. Or Postgres, things like that. So you just see, like, you could just spend, you can get whole certifications in just AWS development, right? You probably get emails about this all the time. Get certified for AWS or those types of things. It's a whole thing. And then you've got Azure. These are the new kid on the block. I had actually a lot of trouble finding an account that I could show you because all of my Microsoft Azure accounts are enterprise accounts, and so I can't show them. But I was able to find one that is still an enterprise account, but they don't have anything running in it, so I think we'll be fine here. You'll notice that it's a lot simpler, right? They don't have as many options in the cloud, and one, because they haven't been around long enough. So they're just playing catch up with AWS, playing catch up with the GCP. But they've got all the core stuff, right? They've got SQL databases. You can create. You got Cosmos DB, which is in theory MongoDB. So it's actually API compatible with Mongo. It's not, but they say it is. And I have personal experience to say it's definitely not API compatible with Mongo. But Cosmos DB is good if you have simple Mongo type things and you just want to use a managed Mongo service. You can use Azure's Cosmos DB. Virtual machines are, droplets. So they don't put a nice little name like computes or EC2. It's just virtual machines. They have load balancers, storage. So like Amazon S3, you'll hear S3, Amazon's S3. That's secure, simple storage. Or simple secure storage, scalable storage, or whatever, and that's just where you can put all your if you have files and it's like a file store, but they give you a URL and you can manage your permissions. Same thing in Google calls them cloud buckets. In Azure, they're just called storage accounts. You can do activate AD monitoring, a lot of different monitoring and stuff like that. So that's basically Azure for you. So we'll look at like manage SQL. First thing Microsoft asks you for is money. So that you can always be guaranteed that Microsoft will do that for you. Most of these other services, they'll let you do a few things for free just to get you hooked. But now Microsoft's like, nope, no, you got to pay for it up front. I don't think they're gunning for our crowd. They're gunning for the big enterprise crowd. So, anyways, that's kind of the rundown, I guess, or really quick overview of all these different clouds, things that you'll end up using probably if you do any of this. If you work with us, that's going to happen. So, fortunately, what I've noticed is that there are very few people that are just so adept at those interfaces or know all those tools or anything. Typically, the documentation looks like it's really deep, but it never works the way the documentation says because these cloud providers are moving so fast to compete with one another. It's such a tight competitive game that their documentation doesn't keep up. And so oftentimes you're dealing with them directly. You're dealing with, I've sat in Chicago, I've sat in Mountain View before with like the developers of Cloud SQL, with the developers of some of these Google cloud products, because I had to fly out there to meet with them because we were so far ahead, and they were just trying to compete. So the documentation wasn't there, so we had to sit and do it together, kind of thing. I Same thing with Amazon, same thing with Azure. Um, yeah, the meetings with Microsoft are a hoot. So I mean, it's because they're so far behind that they're doing everything in their power to get, and they're just throwing money at it. It is unbelievable. Um, if you The one thing is, if you guys go and you work for a large enterprise and you're doing Azure development, and something goes wrong with Azure, the first thing you should go is go to your management and say, tell Microsoft to pay for that. And if you tell Microsoft you have to pay for this because this wasn't ready, they'll just fork over the money. They're in this mode right now, so get it while it's hot because they're just forking over money. It's crazy. I mean, they're just dropping big bills to like just get people to stay on their platform and to adopt new people. So you become a real a real hero with your management to tell Microsoft to pay for it because they will. They won't even ask twice. Be like, okay, sure. How much do you need? Just got to ask for it. So yeah, it's pretty amazing. I think you have to be a Fortune 1000 to do that, but or Fortune 500 to do that. But if you are, they'll pony up the money for it. So any questions about the deployment and stuff, as well as all of that stuff? I know there was a ton of buzzwords in there, and I bet you only caught a fraction of it. You can rewatch it, but quite frankly, guys, it's more about exposure. There's so many tools out there. It's more of listen, and then when someone says something, Google it real quick and be like, okay, yeah, I can see where that fits into at least the bigger picture. That's what I do. I mean, it's not like I've heard of all these tools. Like, probably don't even know what half of them do, but it's something I can Google and check if someone asks about it or wants you to use it or asks you to investigate it to see if it's a good solution. That's most of the time. They're just asking you, hey, will you go and look at this to tell me if this is worth checking into or something for our deployments or whatever. But it comes down to what you're used to and what you want to do. We found the tools that work really well for us, I would say, and we tend to stick with those, as what most teams do. Any questions?
Yeah, Vijay, just out of curiosity, you mentioned about your client who moved from GCP to AWS, where they were driving on which platform they want to be. Is it purely for cost reason? I mean, or
no, management changed.
Oh.
Yeah, it was a pure management thing. Well, the Azure thing was pure management. AWS was because one of the technical directors went to a Google conference and drank the Kool-Aid.
Oh, okay, got it.
And then the Azure was they got a new chief enterprise architect who came from another large Fortune 500 who refused to even hear other words than Microsoft. So there was never an option at that point. It was going to happen one way or another, and he's ended up spending way more than he should because of that. But it's the way it is, right? So and allowed us to get, I don't actually mind Azure. I think it's going in the right direction. It's just not, they're just far behind. I mean, they just don't have the level and the depth that the two others have, in terms of product offerings and quite frankly just quality, because it's tough to get these things to work together all the time, every time, right? So yeah, it had nothing to do with cost. Typically, I would say what people ask me, because it's always, how much is that going to cost? I don't know, right? Because it's all pay for what you use, right? Most of it is. Typically, what the general idea is, if you want to go really cheap but want to deal with issues, go with DigitalOcean. If you want to save a little bit of money, if you want to go, big time, but still feel like you're saving a little bit of money, GCP. Now, if you put them, neck to neck, it's probably on the order of pennies that you're going to save in the end. But GCP, generally, in my experience, at least stuff that I've done, has been cheaper. Hard to say that though, because I do a lot of machine learning and stuff, which is very expensive. So, which the other clouds don't have. So it's kind of hard to say. But commodity to commodity, like compute to EC2, GCP usually wins in terms of price. AWS is somewhere in the middle or pretty close to GCP. If not all the time, it actually ends up beating it on some products. It really just depends. And then Azure just blows everyone else out of the water in terms of cost, but cost isn't what they're concerned about. So I'll give you an example. So when we moved from GCP to Azure for that one, we moved the MySQL instances, managed Cloud SQL from GCP to a managed MySQL instance in Microsoft Azure. As it turns out, the Google Cloud, the Cloud SQL was costing us one replica set, so not like the whole infrastructure, but one was like $30 a month. So really good, not too bad. Equivalent Microsoft SQL instant MySQL instance, $230 a month.
Wow.
So like it just blew it out of the water. But it's also, if you try to run Microsoft SQL Server on GCP, it would be more expensive on GCP than it would be on Azure, right? Because that's a Microsoft product. So it's kind of like Microsoft doesn't really want you to use those managed services on theirs. They want you to use their services and their products. So with that said, Microsoft's gotten really good over the last year or two, especially with their CTO or CEO. They're embracing open source, and they're doing some really great stuff. So I'm not anti Microsoft by any stretch of the imagination. I think they have some growing up to do, but they'll get there. I think they're doing the right things. They're embracing the right stuff. If you think about it, Microsoft now owns a pretty significant portion of the open source community, right? They own GitHub. They bought GitHub. They bought NPM, and they bought. Why am I blanking on the third? There's three that they bought, but they basically bought a bunch of these services, and I mean they're keeping them relatively independent, which is good. We'll see long term what that looks like, but I think they're heading in the right direction. And most of their Azure development's on Linux, so I mean they're embracing open source, so it's not a bad thing. They just have a lot of growing up to do.
BJ, I have a question on the VM. So in our case, so you use virtual machine, the droplet, right?
Yeah, Droplet.
How do you know the bandwidth? So how much the space that you may need for the particular project? Like, you might have estimated that, but over the run you said during the deployment you may face some problem with the SQL. So in that case, you may have to increase the size of the virtual machine. So it's back and forth, or
it's totally back and forth. It's how much do I feel like paying right now? You pick that one, which is usually the smallest one, and then you run into a problem, and it's like, oh, that's an infrastructure problem. Okay, I'll go to the next size, $5 more an extra a month, and then you fight with that for a little bit, and then I tell JC, no, I'm not going to go up one more size, make it work. And he's like, no, we need to go up one more size. I'm like, no, we're not going up one more size. And then I go up one more size. And then the client starts complaining, hey, I need more performance. And then I'm like, fine, I'll go up one more size. It's like that. I mean, it's pretty rare that something just won't work, even on the smallest size. It's that it will barely work, and it will like crash, or it will like run so slow that it's not even funny, kind of thing. That's typically what you see. But it's really...
But even
how little can you pay to get it to work the way you need it to work?
but you may have made an initial decision of how much you're going to start with, right?
Yeah. So, typically our sizes, I'll do like on DigitalOcean, we'll start with like the $10 to $15 a month ones. I mean, unless that's like really simple. Like Clayton and I were working on something with like one Python script that handled some stuff. I mean, that can go on the $5 a month one, right? Mm-hmm. So typically you'll shoot for, from a size perspective, you're looking at AWS, GCP, or Azure also. You're looking at probably two virtual CPUs, right? Two CPUs with probably about 3 to 4 gigabytes of memory. That'll typically get you pretty far. After that, like today, I realized for one of our clients that I had gone real cheap on him and only did one CPU and like 2 gigs of memory, and he was complaining about the performance. And I was saying, well, yeah, you're on cheap infrastructure. What do you expect? And I looked at it, it's like, oh, you're on really freaking cheap infrastructure. Maybe I should bump you up. And so we bumped him up, and now it's fine. But really, it's just a matter of it'll run. It's just more of, well, does it run how you want it to run, kind of thing. And you'll also notice that sometimes you'll have issues with build processes where you'll run out of memory, where you're trying to build Docker containers on the same machine you're running, which is pretty common. That's really where it starts to hurt, and where you where you end up upsizing just because you want enough space to build. Because it's either that or spin up another droplet to do your build server, right? So it's like
So
half dozen the other.
yeah, so running the missile for container and everything, so you can predict that, how much space it probably takes. Like whatever we did in our class, probably sufficient to run in a decent size of
Yeah,
program.
oh yeah. I mean, you shouldn't like to run anything that you guys would probably be doing at first. $10 a month. You probably don't need anything more than $10 to $15 a month.
Okay.
And anything else would probably be overkill.
Okay. Just curious. So this side is fine, but how about the SQL side? So where you'll store a lot of data, right? So how do you determine like whether how much data you are going to keep? And so we are just gathering only speed, which is the numbers. But for example, if you're receiving some pictures and everything that you're storing, all right. So in that case, how do you estimate and how do you determine that?
Yeah, so if you're doing pictures and media,
Yeah.
you don't put them in a database. You actually put them in like S3. Um, we pretty much use S3 for just about everything. Let me see here. So here's like a folder, right? And got a bunch of different stuff in here. Here's one that's 306 megabytes, some backup or something. Um, and so basically, what we've got is just a bunch of different folders, and what these are they basically like let me see. So this is So here's like a URL, right? And then it'll just give you a URL, and then you just upload, use APIs, S3 APIs, and then you can basically upload this folder, and then you can download it. It's like Dropbox. I mean, that's basically what it is. But it's meant for developers, and so you can put them behind your own REST APIs. You can do all that kind of stuff, but you just upload them. It's object storage. As it turns out, DigitalOcean also has an object store. Which is actually just S3. um, and they don't make any qualms about it. It's like, yeah, this is just a wrapper for S3. It's called Spaces here. And unlimited space for $5 a month. So stuff like that. So and API docs, you can use all the same S3 stuff. There it is. First thing on their docs. It's just S3 compatible because they use S3 to store their stuff. But on GCP, it's Google Cloud Buckets, stuff like that. So that's how you plan that. That's infinitely scalable, right? And it's really cheap. I mean, I probably do terabytes a month, and I think I pay like, I don't know, $30 a month or something for that kind of transfer and storage. I mean, it's really it's fractions of pennies. So it's really not that much. But when you're talking about okay, actual like data and things, yeah, I mean that's where it gets really difficult, and that's why we'll talk about it in best practices. But you really need to use managed services for data. You want to move away from manage your own data like what we're doing in Docker, MySQL, and stuff, because you need replica sets, you need redundancy, all those things. That's why you use managed services, and you pay for it too, but it's worth it. Um, we typically don't until we go really big time production with it, or an enterprise customer is willing to pay for it because it is expensive. It is not cheap to do. So you'll see a lot of our initial systems done in just MySQL and Docker, like we did with Bootcamp, and it's good enough, right? I mean, if you set it up, you do backups and things like that. Chances are you're not going to lose it, but you really need to go managed service if you're going to go any beyond. And making a decision when you do that, that is kind of an art in that. And a bit, and it's more of a business decision because then your costs go way up. So it's all about like revenue and the trade-off of revenue and and risk, I guess.
Yeah. So one last question, if nobody's asking. So I just recently noticed that the Google Drive, right?
Mhm.
Don't judge me based on the questions. We're stupid. Please ignore.
Okay.
So the Google Drive, there's an option to store, unlimited images, right? If it is a minimum quality or something like that. So is there any way that in any of the program we can utilize that and store all the data and retrieve from the Google Drive?
Yeah, there's Google Drive APIs and stuff. Um, it would be linked to your Google account, so you'll have to
Yeah.
figure that whole thing out. You know
Yeah,
why they
get
do
into
that
Google
for free?
account. Yeah.
Do you know why they do that for free?
It means to collect our data.
They specifically want to train vision models,
Okay.
so they're actually looking at your pictures.
Okay.
Just so you know, if you care about that. But that's why they're saying it's for free. They
Okay.
they want they just want to bolster their computer vision training, which we get to use when we go and use GCP computer vision. Right? Those are pre-trained models. It's pre-trained on everyone's pictures that they stored in Google Drive.
Okay. Yep.
So
Thank
yeah,
you.
that's also why Google. I think that's why GCP. I mean, Google's like 10 years ahead of everybody in machine learning because they just have the data and they architected it right from the beginning. They were doing machine learning back in '95 when they started. It was the first implementation of that. So way ahead.
Put a link in. I think that's the API. Photos library API.
Oh, cool. Yep. So yeah, you can connect it with your account and all that kind of stuff. So yeah, you could use that. If you figure that out, let me know. That'd be kind of a cool hack. If you don't care about your images, which I mean, generally, if they're just like whiteboard images and stuff, it's kind of like whatever. All right, so let's talk about best practices. This is what we've got here. Um, so these are all things that I preach, but we don't necessarily practice. So I'll point out the ones that I'm preaching about and not practicing. But you should always. Here's the thing: if a client asks you if you do these, you say yes, I do that. And when it comes time to do implementation, you say, do I have time? I'll point those out. Um, so always consider managed services as opposed to implementing something directly. Now in boot camp, right, we implemented everything from scratch, every single thing, right? I mean, except for like we didn't implement like Redis and Mongo and MySQL from scratch. That'd be crazy. But I mean, there was a limit to what we implemented. But for a lot of the things, there's really very little reason to reinvent the wheel. If you're doing something and you're like, I probably think someone's done this before, they have, right? So in fact, if you're saying probably no one's ever done this before, they probably have. You should Google it because and use that because it's probably open source. Um, it will cost more, right? Managed services, that's what it does, but it saves a lot of time. And I go back and forth on this. In fact, tomorrow morning I have a whole open source review with big healthcare company that we're helping out, and big healthcare company, and they're trying to make a decision between going buying an enterprise like workflow management engine versus a open source workflow management engine. And they're an old Microsoft shop. They're trying to get away from it. Actually, they're trying to move to more open source. So there's this whole thrashing within their team, and one of the things that I've been trying to kind of preach to them, which I think they're getting, is that look, you're going to spend the same amount either way, and the reason is because one, you're going to pay massive licenses to an off-the-shelf workflow management engine in this case, software that they install, that they manage, whatever. And yeah, it might make a manager feel better or even an implementer feel better that they can open up a support ticket, but you're at the mercy of the resourcing at that company, the longevity of that company, and what the direction, right, of their board is going, right? You're completely at the mercy of that. You have really very little control over that. You're just going to trust that they keep with your business, and you sign long contracts for that and everything, and you pay for the guarantee. Though there's no guarantees, because it usually comes down to one or two people on the team, and they leave, and then they're screwed, right? Whereas open source, you might say, well, it's free up front. That's awesome. Yeah, well, it's free, but you're also hiring a development team, and you're paying your resources to maintain that. And you're probably going to become the maintainer of that open source, whether you like it or not. But you also get the benefit of the community helping you out too. So there's a trade-off there, right? So, and that's kind of what they're battling with, and always a difficult battle to decide. And one way is not always right for everybody. So, then that's what, like, managed services, it goes into that managed service thing, right? Is the managed service open source? Well, it may be managed service based on open source code, which is great, because then you can actually have a viewpoint into what that managed service is doing. The Red Hat model, right? But at the same time, maybe you don't need like visibility into that. So the next thing is security first. Like I said before, I'll keep harping on it. Always think about security. Every time you write a line of code, how is this line of code going to be exploited? And from an integration standpoint, how is this route going to be used against me? Always think about that. And especially as you're architecting, how is this architecture pattern going to be used against me? Always think about that. Design for innovation. Here's where I typically push for get it done kind of thing. At the same time, we like to design for innovation, which means we always need to keep the big picture in mind. And that's why the best developers are also architects, and the best architects are also developers, because they're the ones coding it and thinking about how it could be expanded in the future and understand the business. That's also why I love having engineers do coding, because engineers typically have the bigger picture in mind. They understand the systems. They also kind of understand what happens from a business standpoint, whether the management thinks they do or not, and all of that kind of stuff, right? So we always, my thing is, don't necessarily be lazy, especially on your data models, right? If you think that is going to grow, make that link table. Yeah, it may be easier to just put that one column in there right now, but make that link table. Always think for scalability, unless you literally don't want to do the project and you're just trying to get it off your plate. And then at that point, it's like, F it, I'm shipping it. But typically, you're not building systems like that, right? You're building for longevity. Here's the big one: don't code, architect. And that's actually a theme through this entire boot camp, right? We actually didn't teach much coding. We just basically threw you guys in the fire and said, like, figure it out. What we focused on was architecture. How do the systems come together? We use code as a tool, but that's the way you should approach coding, right? Don't code, you should architect. Always think the big picture when you're coding it all the way through. And don't code for the sake of coding, because, well, you're just going to waste a bunch of time. Coding's fun for those of us who love to code, but you're going to waste a lot of time if you're just always thinking about how good your code looks, right? So think architect, don't just code. The other thing is, don't overcomplicate your software designs, and we'll keep harping on this through these best practices. Most successful things, right? The most amazing things that we do from a technology pattern, they're so simple, right? I mean, they truly are simple. The things that typically stand the test of time and all of those different things, it's the simplest things that tend to keep trucking. And so we should think about that same thing in software design. There's no reason to overcomplicate it. Don't try to confuse people out of complexity. It's just not worth it, because chances are you're going to confuse yourself 2 weeks later when you have to come back and fix something. So, really think about that. So we've got, I'm going to go through each one of the systems that we have, right? Back end, front end, stuff like that. And JC, cut in here at any point, tag team this. So, our HTTP framework, we're using Express, but it's not always great in all cases, right? We use Fast API for our machine learning because we need to use Python. Then there's other things, maybe don't use JSON. Maybe you need to use gRPC or RESTful web service. Don't use RESTful web service. Use gRPC or something like that. gRPC is, or RPC is a remote protocol um, calls, remote, protocol calls, and what um, what that is just another format for data exchange. Um, the other thing is MQTT. I would not recommend implementing your own broker. And in fact, you might say, well, we implement our own broker. Not really. We use someone else's broker, right? We just used one that we were able to scale horizontally, and that was open source. So we didn't actually implement the MQTT stuff. Um, the authentication in JWT, make sure to time limit your tokens. We didn't really talk a lot about that. I mean, we did kind of, but really make sure to not put a long expiration for that, and make sure that they're stored securely. And then you may want to actually consider managed service for auth, like Passport, which is an NPM library that kind of builds and all this kind of stuff. We build our own authentication at Technicity Modesto, but maybe you should consider, if you're not really into it or don't feel comfortable with the own security authentication mechanism to do your own security assessments, you may want to use something like a Passport. Plus, it comes along with like cool things like Facebook and Google single sign-on and stuff like that. You might want to use. And then RESTful web services. Always thinking about how you're doing your APIs and how you're structuring them. My biggest thing is you need to avoid breaking changes as you push stuff out. You'll know that you've architected a system well when you can rapidly grow but not break. You've architected a system really well. If you are implementing your system, you're constantly, whenever you're making a change and it's breaking something like an old version or something, you probably could have done better on that architecture up front. So that's one of the big things, and that goes back to that architect, don't code, right? Strategies. And
Sorry, real quick, talking about breaking changes, one of the comments I'd like to make on that is don't underestimate the amount of work that you're going to have if you do make a breaking change.
Yeah.
Because I've experienced it firsthand, where it's something I thought was only going to require a little bit of updates throughout the rest of the applications. Because breaking changes, depending upon how many front ends you have, right, you're going to have to go and update all of them, right?
Mm-hmm.
And it can be a lot more. It can really be a lot more work than you would imagine. Especially because I think for me it was supposed to be an afternoon, and it ended up haunting me for the next 2 weeks. So
wait, what was this, JC?
It was one of the updates we made on the Cardinal app about a year ago. Yeah, it was supposed to be really a really quick field name change. We just changed the field name, and yeah, that was causing headaches everywhere. We had to redeploy native apps. We had to do the whole shebang just because of one little variable name. So as much as you want to make those breaking changes, as much as you think it won't be that much, really try to avoid it.
Yeah. So. Yeah, because it will have unintended consequences. And as much as we would love to think we have full test coverage, you never have full test coverage. So
yeah. If it ain't broke, don't fix it. It's true.
Exactly. Structure your REST routes contextually to perform single things. Yeah, go ahead.
Sorry, quick question on the breaking changes. So when you say breaking changes, it's basically you are rewriting some attributes or the variable that you are given initially during the initial deployment, or what does it mean exactly?
But a breaking change means that you'll be changing functionality, or you'll be changing something that's going to break a contract that you have with another system, right, through an API. That's the most concise way, I guess I could say it. Often that could manifest itself in a change in a database variable that's carried through all the way to the front end.
In a physical example, imagine you went into your kitchen one morning and you want to plug your toaster in, and somebody put European outlets in your kitchen.
Yes, exactly. Yeah, good.
I mean, that's a physical example of a breaking change.
Yeah, that's a good example, right? And now none of your shit plugs in, right? That's a good example. So that's what a breaking change is. Whereas a non-breaking change is additive, right? It's just something that you add on top. And typically you'll do it in such a way that you'll think about it, and in fact, you do it with your versioning of your APIs, right? Which is my first point here. What you can do is you can version your API. So V1 means there's no breaking changes in it. So as long as you can do it, and then you jump to V2 if you're going to have something majorly breaking. But what you can do with V1 to V2 is you can actually fall back. So you can have some of your clients, whether it's a front end or a mobile app or something, it can be communicating with V1, right? But you might have a V2 out there, and then you can say, well, some of these routes will actually use V2 because, and you just have to be smart about how that works. We've been relatively good through all of our projects architecturally to not have very many major breaking changes. Um, Maybe that Cardinal one is one of the few that I can think of. Most of the time, they're additive, where you're just adding features, and they were architected in such a way that I like to call it accidentally good architecture, where you had no idea that that was the way it was going to happen, but hey, that actually worked out pretty well. It was an additive change. That feature, flipped in really nicely. There's very little impact to the system, and you could still allow all of your other systems to not be affected by that change. So
Yeah, and to continue that analogy, and an additive change, right, in your kitchen would be you still have your original outlet, now you've got the European one underneath. So you can still plug it in, but if you need to plug in the new one, right, you can plug that in too.
Yeah. And to make it real elegant, you'd probably just replace one of the outlets in there, right? So that there was the one outlet, and then you run 220 to that and the 110 to the top one. Yeah, never mind. Because now I'm thinking about elegant. Like, how can I make that API? How can I make that breaking change more elegant? Because I don't really want to cut into the wall, right? To add a whole new faceplate. That's nasty. I just want to actually add the, So there's some art to figuring out what an additive or breaking change might look like, right?
Yeah, you
Are
mentioned
you trolling me, BJ?
Yeah, right. All right. So, we done with best practices on the back end. All right. Um, yeah, databases and relational data modeling. Obviously, MySQL, we've been harping on this. It's not the only one out there. It's the one that we're most familiar with. It's a tool we like. I know it scales. I've scaled it to hundreds of terabytes, close to a petabyte before, and it works. You have to do some nice stuff with it, but it works. Postgres is another one that's out there. It doesn't scale as well in my experience, but it's got some cool things like geospatial mapping, JSON support, things like native. Although MySQL has that now too, as of recently. Managed services are good. Keep saying that. Do not if you plan on scale and you're willing to pay for it, definitely do the managed service with your database, and choose a database that has a managed service option that you can always move to, even if you're doing it locally. Plan ahead, right? This is the architect, don't code. This is architect starting with your data model. Figure out how your data model is, and that's where the most thrashing and the most pain and suffering with breaking changes occurs, is in your data model. So always try to structure it consistently and plan ahead. Data-driven applications, enumerate everything. The data model should speak for itself. In fact, we typically speak in data models, not APIs. To the client, we may speak to APIs, but when we talk to each other, we actually speak in data models. Wouldn't you agree with that, JC?
Yeah. Yeah, there's no way that you're going to understand the API without understanding the data model, at least in terms of designing the API, right?
Right. Yeah, your data model stems from your API stems from your data model, 100%. Efficiency, always think about what's going on in those and how they can be impacted from an efficiency standpoint. Got to plan that accordingly. Performance is kind of the same way, right? How many transactions are you making with the database? Can you do that a little bit more efficiently? Can you do that better? Things like that. And then we didn't even talk about this, but there is a concept of transactions, ASIC transactions and stuff, where you can actually do start transaction, commits, and rollbacks. Where, if you're actually starting a transaction in MySQL, you can start a transaction, do a bunch of activity, and then commit it. But if you do all that activity and you don't commit, then it doesn't actually keep in your database. And so that's a good way to do testing and verification, as well as in production systems, to make sure that if you have a lot of disjointed operations on your data, that you can actually put them all in a transaction and then commit it once you verify that everything is good and works. So look into, just so you know and you've exposed to transactions. Transactions get very hard on microservices. And in fact, Mongo, up until this latest release, didn't actually even have transaction management because of the performance implications of it. So the community is kind of split. The database community is split on transactions, I would say, using them or don't. I'll go back and forth. Typically, I'll say no transaction. I think it overcomplicates things. Um, the other thing is, everyone has a NoSQL solution. Everyone's going to push one onto you. MongoDB is a good one, probably the most common that you'll hear about, probably the most stable, I would say. API now as well as business and open source. But MongoDB is not always the right one, but it will probably work for most cases. It's not a bad one to always put at the top of your list when you're thinking about what NoSQL to use. Another cool one that I've been looking at recently is FaunaDB. It's a pretty cool transactional, operational focused database. I haven't used it in production, so I don't know, but it's kind of a cool concept, NoSQL. With NoSQL, you have sharding and replica sets. We talked about in databases with partitions and indexes. With NoSQL, especially Mongo has a concept of sharding, where you actually will cut all your data and documents into into certain patterns to increase performance. And you don't want to have to do that. You want a managed service to deal with that. There's automated ways to do sharding, so let someone who has that experience do that. In NoSQL, don't be afraid to duplicate data. In a relational world, you don't want to duplicate data, right? You want to normalize. In NoSQL, it's the opposite. It's okay to duplicate data. Just make sure it's consistent. You keep track of it. I said here, there's no concept of transaction in NoSQL. Can't manage your transactions, so do it yourself. So, all right. Anything on databases before we move on to microservices?
Mm-mm.
All right, microservices. We spent a little bit. We actually spent a lot of time on microservices. Maybe we just didn't call them microservices, but everything we did was a microservice in a sense, right? Our cloud was a big microservice, but it was really our back end. But it was still a microservice. Our training, our model train, our prediction, trip time and prediction was a microservice. MQTT was a microservice, right? Things like that. So some of the things that you want to think about are product-oriented architectures. So what I've kind of pioneered my architecture career on, I guess, at least initially, and it shifts and ebbs and flows, but is orienting your microservices to more of a product-oriented architecture. So you saw that example that we did, that use case in an earlier lecture about how we actually split it up: dealer service, boat service, data service, things like that. Those are your microservices. It tends to be a pretty nice way to split up logically thinking about it. The other thing about microservices is you can have multiple teams work on different ones, and you can also split out microservices. So if one microservice has a lot of processing, maybe use a different language that's faster for that kind of thing. Whereas instead, if you had one what we'll call monolith, you're kind of tied with the language that monolith is in. You can't switch languages in and out. But with microservices, and you're just speaking APIs between them, you have the advantage of picking the language that's right for that microservice. In fact, we did that last week or 2 weeks ago when we did the or last week when we did the machine learning thing, right? Because our gateway was in Node. Our MQTT service was in Node because that was what's available. But then our training service, our machine learning training service, was in Python. Right? So we were able to do that because we split them up into microservices. So it's really really a systems-oriented concept, but kind of taking advantage of implementation flexibility with that. So gateway is a primary. I would highly recommend to never have all your microservices interact with each other and not have a gateway. And the reason is because you'll have a lot of, you can imagine that, you could have 10 different microservices and they all communicate with each other. They can all share, or have their own databases. But then that gets off the hook really fast. I mean, imagine you're in a meeting sitting around a conference table and everyone is talking. Everyone's having their own conversations with everyone else, right? And that's a really frustrating thing. Whereas you really just want one person presenting and everyone listening and having an orderly kind of question and answer sort of thing. That's what the gateway does. The gateway acts as the orchestrator, the presenter, and kind of manages all of that conversation. Whereas if you had microservices, just everyone in the meeting just talking over each other, that's what the microservices would be doing. And keeping information consistent and making sure other microservices didn't miss the information when it affected their data and all this kind of stuff. It's a very difficult thing. So you always want an orchestrator. And so always think about using some sort of gateway. You can cache to speed things up. You always want to think about how to make things faster. And so caching data is always good. Transactions are going to be pretty important because if multiple microservices are involved in a gateway transaction, you have to make sure that all the microservices performed the way you want them to. And if one didn't, how do you roll back the others, right? On a multi-step microservice transaction. So make sure that universal unique identifiers are good for microservices. That's why we use UIDs or object IDs. Because one database table, right? If you use integers, 1, 2, 3, 4, it's going to conflict with someone else's 1, 2, 3, 4. So if you use UIDs, every record in your system, regardless of where they are or which database or what infrastructure they're on, will have a unique identifier if you just generate UIDs all over the place. Then, of course, security is paramount to make sure that all the microservices use the same authorization credentials, but at the same time are also secured with that. So you just got to make sure that they also share a good authentication pattern with each other and with the gateway. So best practices with microservices, big ones. Anything you want to add to that, JC?
Nope.
All right. Then we got front end. Front end best practices are numerous, but the biggest ones that I'm thinking of right now, I guess, are look for boilerplates and bootstrapping. In fact, we did that. All right, we used Create React App to give us basically all that Webpack stuff and everything. It basically did all the kind of the tedious stuff for us. It's going to save you a lot of time. Don't reinvent the wheel on that stuff. Don't try to start from scratch unless you're just trying to learn, or you're just kind of doing it for gee whiz kind of thing. Don't try to do something you care about time wise to try to recreate that. I would say don't try to hard code much. You want to do a configuration file. In fact, we did that, right? In fact, you saw that in like week 9. And before, we actually made a configuration file for not only our front end but our back end too, because we needed to do that in order to manage deployment, setting variables and things like that. It's going to allow you to change something in one place as opposed to many different places through your entire app. That goes for just about anything, but especially the front end. You can never assume that the back end is going to return what you want, and so you always have to be able to handle multiple things, and that impacts the UX a lot. And you have to think through the user experience of what happens if the backend doesn't return what you think it does. What does the user see? Does it just say a server error, or do they actually get a good explanation? Does it try again? You got to think through all those things. It's pretty tedious. Big thing is you got to validate user input. A lot of times you don't validate user input, and that's where SQL injection can happen. You'll hear about that. Stuff like that. Always validate user input. Plus, it just makes for a better user experience. So if someone tries to submit an email and it's not a valid email, then do you let your backend try to tell them that, or do you actually stop it before it gets even close to your backend? Probably stop it before it gets to the backend because the front end is a better user experience there. You can cache in the front end too by optimizing your backend calls. And then my biggest thing is UX centered design. You always got to think about who's using it. And when you're doing your front end, always think about who's using your front end. Don't develop for yourself, develop for who your users are. And oftentimes, especially in Microsoft, you'll see experiences that were developed by developers. And you know that it was developed by developers. That's how they would use it. It's not how the rest of us want to use it, though. So Always think about that. And there are testing frameworks like Jest, so you can do, and Cypress. Cypress is a good one. We use a lot of Cypress. So there's that. And then with context, always think about your components. Break down your complex objects into two different types of things: functional and presentational. Presentational components are what it says. It's how where you handle the styles, how they look, things like that. And then the functional components handle all the different logic and stuff like fetching from the server, managing state, things like that. So you'll see a lot of design practices where you break up, you break up presentation from functional. And then you can obviously you have to plan out your context structure. It's very similar to backend data modeling, right? Interestingly enough, because context is all about how you actually do how you manage your data in your front end. And then another thing that we did not go over this entire boot camp, but you may want to look into, is something called TypeScript, which is a language in and of itself, but it's a superset of JavaScript that allows for typing. I think I mentioned it a few times before, but it's for type checkers, so you can actually verify, different objects and things that are moving through your code. It probably doesn't mean much to you right now, but as you develop more and you develop in bigger teams, TypeScript becomes a very, and you're doing a lot of maintenance stuff, TypeScript becomes very nice because it'll catch errors before you even realize it. And then JC, you added this. It looks like this is a good one.
Yeah, so one of the things that we didn't get into too much with the use of context and hooks was reducers. And in earlier versions of React, before hooks was available, it was really common to use an external library called Redux, which integrates really well with React, but isn't necessarily required to be used with React. So it's in and of itself its own library. But without talking too much about that, this idea of reducers along with context gives you a Redux feel if you ever look into it. And what it allows you to do is, before you modify the state that's held within your context, you have the opportunity of controlling what happens before that state gets updated. Perhaps you have some kind of middleware and you actually want to add in validation to an email that you're storing inside, right? You could actually have a step where you say, this is an email, right? It has an ampersand, it has a domain and everything else. And if you want to look into a little bit more of that, just go on Google and look up useReducer as a hook. And if, in order for you to really kind of add that middleware in, you'll have to look up some packages that implement what are called thunks. And thunks are basically just functions that allow you to wrap other functions that occur after an action occurs. And it's how you get into this process of being able to do asynchronous calls inside of state updates and whatnot.
Yeah, front end is actually, in my opinion, harder than back end to do well.
There's one other thing I'd like to add in here is front end, when it comes to display, is very is very specific to the UX, to the point where it is very challenging to generalize. And so everything changes so quickly. I think we found that flatter designs seem to work better.
Yeah, flatter designs do work better. Which leads us into UI UX. Designed for various devices. We've been saying that the whole time. Should support mobile and large desktops. That's that responsive characteristic. We've had lots of discussions about that. Designed for cross-browser compatibility. It's getting easier now because now Microsoft uses Chromium, which is Google Chrome's engine. So really the odd man out is Safari and Firefox, but Firefox is pretty consistent. Safari tends to like to do its own thing sometimes, but Safari has such a tiny user base that typically will say, yeah, well, use Chrome. If someone says it doesn't work on Safari, we'll say use Chrome. So that's a pretty common thing to hear. When pulling font or images from external services, you should probably provide backups if they can't be served. Oftentimes you'll pull like fonts and things from like Google CDNs, content delivery networks, things that you don't control and own. So you may want to have backups for those because you never know when those will go down. because typically you don't pay for those, so there's no guarantee that they'll be there. Um, and then best designer steal. So take inspiration from other websites. Whenever I need to go do a new design, I'll just Google image search, cool design techniques for tables, or cool design techniques for, I don't know, something, right? Um, Charts or graphs, and just kind of get inspiration from those. And then don't jump using a design framework too quickly. You can. That's one of those where it's don't reinvent the wheel. Oftentimes, like if you're, using things like Material UI or something, it's really heavy. In fact, we're going through a rewrite right now of a system. I'll use Material UI, which is a design framework, and frankly, it's just so heavy, so bloated. You use a fraction of what's in there, and most of the stuff you can pretty much do yourself. Like, for example, Material UI has like nice things for like tabs, and you can do theming, or what place you can put a color, and you can put, different, like all the buttons and everything. It's very Android like, because it's Material UI is Google's design framework. Um, but I found over time that it's just so heavy and bloated, and you end up making such opinionated decisions about your design because you're relying on this design framework, that it was much easier to just do our own with plain CSS and plain JavaScript. And we've actually kind of come up with our own kind of design framework. Um, we'd probably get lined up in shot execution style if a designer heard us say that it was a design framework. But we kind of come up with our own thing, which is very flat. It's one CSS file, and it's all just kind of themed that way. So maybe consider making the components yourself as opposed to going with a design framework. And then Git. These are my suggestions. Everyone has a different feeling on this, but commit early, commit often. Commits are cheap, right? Just electrons. So it's a good way to backen up code. Use branches all the time. It's a good way to show other people code or get their view on it. Definitely do merge requests. That's going to be it's going to save everyone a lot of time. It's also a good way to see what's changed, what's not changed. It's also, when you're rapidly developing code and multiple people on a team are doing it, it keeps things in line, and keeps things consistent. So commit branch model and merge model is good. And take some time to write a scripted commit message. This is, of course, one that I never do, but you should do it, right? Notice the little comic down there. It's as a project drags on, my git commit messages get less and less informative, right? So you start like really good, and then at the end it's just whatever, ASDF. Or WIP, work in progress. Commit messages are good, but you should spend some time to learn Git. We really should. It's painful, but spend some time at it. Your team will thank you, and your future self will too.
And a reason that a lot of times that they suggest, for example, imperative move being beneficial for your Git commits is the fact that a lot of Git commits they're essentially deltas upon each other. And so the idea is, if you're about to apply a certain set of commits, it's easier to understand when they are in the imperative mood, meaning, for example, add a button below the text, right? Their imperative move just means commands, right? So it's essentially you're adding a bunch of different commands, and the idea is that it's the sum of these imperative statements that's going to make the difference in what you're going to see after a merge, for example.
Mm-hmm. So definitely consider that strategy, and we'll keep harping on it. If you start developing in our team, we'll just keep beating you over the head with merge requests and things until you conform. Because that's just, it's in the end, when everyone's doing that, it really does save a lot of time for everybody involved. And then best practices and thoughts on the embedded domain. That's the part of the boot camp and Connect system we didn't get into, because at some point you just you got to say, look, we only have 12 weeks. We already covered too much, right? Walking that line between demoralization and actually teaching anything. So if we would have thrown the embedded domain on you guys, it would have just been, you guys probably should have walked from the beginning. So, few thoughts. Energy is more important than cost. oftentimes in embedded systems, because that's the thing, right? Especially mobility, you don't have an infinite power source. Even in non-mobile applications, I was talking today about an application where you didn't necessarily have power. It was in a room, but you didn't have power at that place, and they couldn't afford to put a bunch of electrical infrastructure to that place. And so we needed a way to keep it, and installation had to be quick and easy. So we needed a way to get power there. So does that mean adding a solar panel? Does that mean putting a massive battery on it? Does it mean, if you do that, can you, how do you recharge it? Is there a good way to recharge? Is there wireless power? All those different things. So that's typically a pretty common discussion that we have. Um, and then also keep in mind, communications take a really freaking load of energy. So whenever you open up a socket, whenever you turn on a radio to spew a Wi-Fi message or a Bluetooth message, it takes a lot of power. A lot of power. So you try to minimize those if you can. The other thing is data transfer is exceptionally expensive. You know how much you pay for your cell phone bill? Well, it's about the same in IoT telemetry. It's just really, really expensive. So always try to think about how data fees apply. In fact, in our own managed IoT service, which we'll close with here, is we actually came up with, well, JC did. I'll take credit for it though. We came up with a what we call the IoT single packet protocol, and in just 26 bytes of data, you can send, or 32 or something, you can send an entire message fully encrypted. So just little bursts of data, right? Now we do it. It's over UDP, not TCP, so it's not particularly guaranteed that it'll reach there. Usually it reaches there, so it's not guaranteed. So there's trade-offs, but there are ways of coming up with strategies to get really tiny amounts of data to where you need them to go. Fully featured HTTP REST is pretty heavy of a protocol, so you only do it when you have to. So there's lots, and that's why MQTT is popular. It's really low overhead kind of protocol, really efficient in terms of data transfer. Problem is it's energy expensive because you have to keep socket open all the time. So can't have your cake and eat it too, right? So we talked about this through it, was establishing a secure provisioning mechanism. All of that different kind of stuff. How devices connect. How do you put them in manufacturing? How do you put their certificates in them? How do you validate their identity? All of those different things. How do you use the eFuse on the actual, processor? How do you use the trust zone? All of those different things in the embedded domain that you have to worry about from not only a security standpoint, but just ease of use and the user experience of actually plugging that in. Is grandma going to use this? How is she going to actually get this thing hooked up? All of those considerations. And then always design for expansion, handle firmware updates, complex functions in the cloud need to be handled there, and all that kind of stuff. That the big thing that I push for embedded device is modularity. The big thing about embedded work is that a lot of times embedded engineers are really, really focused on making things as small as possible. When I say I mean small, I mean they're so used to working within the constraints of resources, meaning, they don't have much memory to work with, they don't have much processing power to work with, that they don't think outside of that box of being able to say, look, all right, I'm actually architecting for the future. Yeah, I'm going to put, it's like 3 pennies more expensive, it's 3 cents more expensive, but I'm going to put that little extra memory on there. Or, yeah, it's a little more, it's a bigger program that I'd want to put on there, but I'm going to do it anyways because I know that we're going to have to grow, or that it's for this specific application. So I'm always a proponent of spending a little more on your embedded device than it is, unless it's really dedicated and you're going to make millions of them and they need to be perfect in terms of every cost out, like an automotive application, right? You strip every penny you can out of that thing because, well, you're going to make millions of them. So you got to be flexible with it. But I'm always kind of a proponent of making your IoT devices a little more powerful and a little bit more flexible than trying to strip and optimize before you're even deployed out in the world. So that's kind of my thoughts on the embedded domain. And I'll let JC do this because he wrote this slide up.
Yeah, so I know a lot of people have asked some questions just in general about programming design in terms of what are some of the best practices that you should follow. What do you do when you're trying to design a program? What kind of maybe like what compass can you use, right, to know whether or not you're doing it right? And right's it's such an opinionated word because like when you you do some research about guidelines and whatnot for writing well architected code, and there's so much opinion that you get into almost religious debates, right? And but some of the concepts and whatnot, they hold a lot of merit, and that's why I've got a little bit of a caution up here at the top, just saying, they're meant as guidance and they're not some set of dogmatic laws, even though you will find people who are zealots on particular ones of these concepts. Like you might have somebody, for example, I'm going to talk a little bit about functional programming. They can just say, look, functional programming is the only thing there is, and they can't be anything else, and don't show anything about object-oriented programming to me. I guess I personally am in the boat where I like to take what feels like works really well out of each of them and mix and match. But just going from top to bottom here, the first one is honestly like it's the most natural one, is staying dry, which is don't repeat yourself. You notice that you've taken a piece of code and you're copy and pasting it. You've done it, maybe done it for the third time now. That might be a good time to think about generalizing this, abstracting it to a function, into a class, whatever it may be, so you don't have to keep rewriting that code, and now you can just configure it for each of those situations. And that can be used in the context of not just one single piece of program, but you could consider that for even like a microservice. Maybe you notice they've got 3 different microservices. A perfect example of this is actually iOttery, right? And you think about, we've got a bunch of different cloud connected IoT systems, and they all seem to be using this same core set of functionality, right? And what you can do is you can take that, abstract it, create your own service that'll do that, and then reuse that as the backbone for all of these other ones, so that you're not re-implementing all of this IoT infrastructure every time, right? So the dry principle is not just for writing a single sheet of code. It applies for everything you're talking about for building software. Now, the next topic here is functional programming. One of the nice things about functional programming is it tries to be very pure, in the sense that you want to have a set of inputs, do operations on those inputs, and provide an output. So it very much fits that black box idea, where you've got I got a process being applied to some inputs and then something coming out. What they try to do in the lingo of functional programming and inside of functions is avoid what are called side effects. Now, side effects are anything that cause some kind of permanent change. Technically, even printing to your screen, doing a console log is a side effect, or changing a record in a database, any of those kind of things. Now, can you make a program that actually does something without side effects? No. Right? You have to have side effects at some point, but the idea is that you save the side effects for when you absolutely need them, because when you can have what are called these pure functions, it makes them a lot easier to compose. You can think of mathematics operations. Maybe you apply a sine function, then you want to take an average of that. You don't need to have 4 different functions for the composition of those. You just need 2, right? And you can see how that will go and expand. So those are some of the neat things about functional programming. I mean, it is really clean and powerful when you use it right. Now, the next one here is object-oriented programming. This was huge. I don't know, BJ, was it huge before the 90s? I know I got into OO when I was learning Java, because Java itself, not JavaScript, is a language that is strictly written to force you to write in a object-oriented programming paradigm, right?
Yeah, I mean the '90s were object-oriented heyday. That's when object-oriented was born. Java was born in '95, so.
Now, it really is a powerful paradigm, in the sense that there's a lot of real world objects that are modeled very elegantly and cleanly in object-oriented concepts, right? I think where OOP seems to be a little bit difficult is when you try to create a taxonomy of things that aren't necessarily represented well by objects, and you start creating classes that people don't really understand what they mean. But in general, it comes with its own set of you've got huge books on design patterns. Design patterns are essentially strategies that you can use to solve particular problems in a very elegant and maintainable way. One that we've even used in some of our embedded work is what's called an observer pattern. So you have this pattern where you have essentially a subject, right? And you have things that want to know when this subject has updated. So what they do is they actually subscribe to the subject, right? And it maintains its list of things that have subscribed to it. And as soon as it updates, it will send out a notification, and it'll call the notification method on all of these subscribers, and it'll provide the new data, right? And why is that handy is because you don't have to worry anymore about when that notification is going to occur. You've decoupled those things, and you can see tons of examples of that. One thing, if you're interested in about this, look up the list of solid principles. There's If you pull that up on Wikipedia, you'll see the list out. I think one of the ones that I really like is it's called the, let's see, interface segregation principle, which is having you have many different specific interfaces rather than one huge generalized one. And the other one that's really nice is what's essentially called design to contract. And we've had a lot of discussions about this, even for API design, is like essentially defining those interfaces between the different pieces of your software such that you can focus on modular pieces rather than trying to absorb it all and solve the entire problem at once. So just like I said here at the end here, just don't go overboard and try to define a taxonomy of the entire world. One of the big critiques of object-oriented programming is you want to get the banana, but you actually get the banana, the gorilla, and the whole entire jungle with it, right? And so
that's true.
If you ever go down the OOP rabbit hole, you'll know what you'll have a feeling for what that means. And the last one here is just in general abstraction. Without it, we'd be programming in binary, right? Too much of it, and you'll probably miss deadlines. So if you find out you're violating the drive principle more than you should, you probably should abstract, right? And your abstractions contain various forms. They can be functions, classes, design patterns, an entire service, right? Just think about what is it that's being copied, right? It's not always just a few lines of code.
Yep, that dry principle's a big one. Harp and harp and harp on that one. I think that's what we got. And that is it. Let me show you IOTRY. So we've been talking about IOTRY through this entire thing, and as it turns out, we kind of actually implemented IOTRY at a simple level through this entire boot camp. So we found that we were implementing multiple IoT systems over and over and over. And we also found that even after implementing systems in AWS IoT and Google Core IoT and other managed IoT services, that they were very, very locked into the platform as a service model. You had to pay lots of money, and it's kind of it was a snowball, had a snowball effect where, there are a lot of hidden things in it. So Google or Microsoft will sell you, yeah, use our IoT service. It's really great. And then it is for the first, simple example. And then you realize, oh, I need authentication. Oh, I have to use your authentication service. Oh, okay. How much that cost? Oh, I have to use your PubSub network. How much does that cost? Oh, I have to use your container registry. How much does that cost? And then it just starts to snowball over and over and over. And it's by design. They do the same thing that we did with IoT, right? They're all managed services. And so what we wanted to try to do was to take, IoT and simplify it to a point where you could still do all the enterprise functions, but you could still be somewhat independent. And so we designed IOTRY to be completely portable. So that means they can be deployed on AWS, GCP, Azure, any of those, DigitalOcean, any of those that you want. But it allows you to be pretty flexible. You need flexible hardware. It's developer friendly. It's designed for machine learning. Let's see how that works. Whole video you can watch, and that kind of stuff. And really, what it comes down to is it's not open source, but all of the libraries and interfaces to it are open source. We've open sourced all of those. Um, it's not that we haven't open sourced it because we don't want to. It's just that we haven't gotten around to it yet. So there's no reason to not, there's many open source platforms for IoT. So let me see if I can log in here. Hopefully I can log in here. Oh, I know why. Just a second. Jeez. This is, there we go. All right. All right. So these are some of our little IoT boards that Clayton built for us. Actually, I have one right here. It's even got the little IoT logo on there. So it's if you guys are interested, you guys can play with these. We'll send you one. Um, they're pretty cool little boards. Um, but anyways, you could have many different teams. We actually have a couple of enterprises on here already. We have like a 3D print shop that monitors some of their heat pumps on here when they create their stuff. We've got a number, but basically what you have is you'll notice that we start talking about like feature definitions, right? In machine learning. Well, we force you to actually define your features up front so that we can do something called auto ML, where you actually have a strategy by which if you have enough data in the system, it will actually take your features, which are your data types, and based on your actual data type, it will this is like local IP address or CPU load or CPU temperature coming off of the device. We can start training models based on the features, and with a simple strategy of just picking what kind of output you want. I mean, obviously you have to do some configuration, but with just a dashboard, you can say, I want this output, and it'll automatically determine what features are best based on the data that's in there, and then be able to do automatic outputs and predictions for those. Then you can also define different device types like a hub and stuff like that. Let me see. Trying to see if I've got a good one here. So here's a good one. One of our Electron is a battery, a mobile battery unit kind of thing, and there's many different types of devices. They have a battery sensor and a battery pack, things like that. They have data types that are associated with device types: voltage, current, regen. They have settings. So you can see like all the different things you can do, but then you can also do things like define functions. So we had in cloud functions and things in some of those like GCP that we showed you, or they're called Lambda functions in AWS. So if you want to just define, like, let's say there's a webhook that comes in, webhook being data comes in, you want it to generate a specific, you want it to hit, so that let me start over. So let's say you've got data that's coming in from a device. So data posts via REST route into IOTRI. IOTRI, then you can make a webhook, and a webhook is just an action. So there's tons of different actions in IOTRI. Basically anything that can happen in the system, you can say, this is an action, that a post data action, and I want it to hit either a URL. So in this case, this is just an ngrok URL, or to another system, what we call a value-added system, or it's an IOTERY function. And an IOTERY function is allows us to code directly in the browser, and it will automatically, you just code in JavaScript, it will automatically package this up and deploy it into a Docker container and give you a little REST route. So if you just have like rules that you need to run or anything, kind of gives you that ability, but all in you know, one infrastructure setting. So you don't have to do any tool chain setups or anything. You can basically just do it all right here. You can kind of see how that's working, right? Where it's just counting. So this code just counts up 1, 2, 3, and then you can just keep running and it'll just keep counting. And you can do stores, and you can see the logs and all this kind of stuff from your little cloud function, which is just a little Express server in the back end actually. And you can do settings and stuff, and then you can also hit that. It's just a little REST route. So lots of good stuff. You can also do embeddable charts where you can just create a new chart based on your data, and you can automatically assign your data and all this kind of stuff. And you can also do networks, and we also have a managed. You go to the documentation here. We have an account manager API. So basically, you can build your own dashboard if you want. Like this front end that you see, there's APIs that you can build. You can do an embedded. The embedded API allows you to do all the different stuff that you need to do with any device. It's bring your own device. So, and then consumer API allows you to kind of manage your own users. One thing about IOTERY that we didn't like about the others was that IOTERY kind of allows you to manage your own user base. IOTERY doesn't need to know anything about your users, which makes it HIPAA compliant and all those different things for medical devices. All we need is an ID from you and a key and a secret, and then you manage your own stuff, your own user credentials. We also have a fully managed MQTT service that you can see here. So you don't have to do your own MQTT anymore, right? Well, you built it, but you don't necessarily have to. And then we also have a IOTERY single packet protocol, which is a really tiny UDP-based protocol for sending data. Keep your stuff down. And then we also have a bunch of SDKs, software development kits, Node SDK, Python SDK. We have a MATLAB one. And then we have some tutorials too. So anyways, a little bit of a sales pitch, I guess, but to kind of show you that, you know, from an actual device standpoint, you know, these are what kind of managed services we can do. And we actually, if you want to work on this, we do have work to be done on this. There's always work to be done on IOTERY, but you know, we can. There just to really show you like all the different stuff. Here's the data that comes in, and I don't know, Clayton, do you have a board running right now? I don't know if there's yeah, but anyways, we'd have to get that booted up and running. But basically, just do all the the data and all this kind of stuff. So anyways, we also have provisioning strategies for claim codes, so generate your own QR codes and all that different stuff. So really, it just comes down to sending commands, because we didn't actually talk about sending commands, but verifying and doing the command structures and all this kind of stuff, posting and executing commands, all this kind of stuff. Who created this? Like you. Who created that?
It was just a test.
So anyways, there's you can see that there was this is an example of a simplified managed service for IoT that's very similar to kind of the system that we built with the vehicles. So you can set it up and do all the authentication and all this kind of good stuff. So anyways, that's kind of IOTERY in a really quick nutshell. You can check it out and look at all the SDKs and all that kind of good stuff for all the different stuff, device SDKs. You can get a list of your command instances and all this kind of good stuff. So, anyways, that's iOttery in a nutshell. Um, go forth and sell it to everyone you know, I guess is the message. Any questions?
ESP32 is the Espressif 32 room processors.
Yep. Yeah, it is. Yeah,
Okay.
that's one of the processors that we use for like really rapid prototype kind of stuff because they're so cheap. They're really powerful. You can run MicroPython on them, so you can actually code in Python. And that's actually what this board that I was showing you. We actually have 3D printed cases now. This is the ESP.
Okay.
But we also have a fully fledged American-made IoT board that's made by a Wisconsin manufacturer, SMT, that we do firmware for. That's fully Dockerized and containerized on a Sama 5, which is a microchip platform. And then we're working on, I don't know, microchip's been slow on this, but we're working on an embedded microchip Wi-Fi. So microchip is finally doing a PIC32 with an embedded Wi-Fi, which is, what the ESP has, right? Wi-Fi, Bluetooth, everything on the can. Finally, microchip is doing that, but it's slow. It's so slow because we're the first one to get it, and we haven't even gotten it yet. It should be 5 days. So we're in the early adopter program because our contract manufacturer out in Wisconsin is one of the largest, if not the largest, microchip designer and a contract manufacturer in the United States. So yeah, we've worked with a bunch of different platforms. We also like Raspberry Pis. Raspberry Pis are fun. They're really good for prototyping. Never put one of those things in production. It'll bite you in the ass real fast. But yeah, they're pretty quick to get going. And then done things with a lot with battery, a lot of BMS, battery management systems. We use a lot of TI chips, some of the active balancing, and then of course a lot of ARM stuff for the more embedded Linux stuff, which is what the Sama 5 is. It's an embedded ARM Cortex. I think it's a 7. Is it a 7 or a 9, Clayton? I forget. I think
it's 7. Yeah.
7. A7.
Single core.
Yeah. You can get them in dual core though, I think, but I don't think it's quite available yet in production. I think they're still early adopter. But yeah, they come from the Atmel, I think, the Atmel line. But Microchip bought Atmel 2 years ago. So I think it's the old AVR32 platform. Honestly, it looks very similar because I used to develop on those. If you know what all the gibberish of the embedded stuff. But Shweta, I know you come from that space.
No, I recently used the Room 32 for one of the designs, so it just flashed when I saw ESP32 there on the screen.
Oh yeah, no, we've been doing a lot of cool stuff with it. Yeah, in fact, that's what just spent the last couple of days. So, but yeah, if you want to deal with that, Shweta, that could be cool. There's a lot of stuff to be done on our little platform.
Yeah.
But all right, well that is it. That completes your 2 weeks of hell or 12 weeks of hell boot camp. So we'll record anything you guys want to say or anything. Of course, we can do better, and then we will stop recording, and then you can really just lay into us and give us your really honest feedback. So anything nice to say, anything any kind of improvements that can be made, we are all ears.
Vijay, let me start. I'll start first. So for me, it's all by accident. I never thought I'll be attending a boot camp. I just talked to Grace, and the next day I'm in the boot camp. I have no idea what it is.
I'm surprised you're still here, Arif. That honestly, if that's one day decision, yeah. That's a true testament to you.
So, and I have zero knowledge about the programming and all this stuff. The first, you keep telling that first 4 weeks is going to be dry, and that gives us a little more comfort. That is a main source that even though I don't understand anything, so your words here and there, you don't understand, don't worry, keep hang on, you'll understand. So I really followed that, and so oftentimes little frustration because sometimes you have to watch 4 or 5 times the same video again and again and go some Google search and everything. But yeah, now I'm a little comfortable, and I wish the picture you showed me today, the whole map of MQTT, everything, I was expecting the first day. All right, that would helpful to understand what's going on. But I maybe that there's a strategy too that keeps me thinking how and everything. Now it makes sense, right? Now it makes sense. The whole picture makes sense to me. You said 4 or 5 weeks. It takes 7 weeks for me. Even more than that, I don't know. Still, there's a lot to learn, and one biggest thing is like the coding. It's in front of us. It really helps. It really helps too. Not in the class for sure, but after watching the recording again, it really helps and to understand, especially people like me who have zero idea about coding. And I thought it's some different island, and coding and software programming it's not my thing. That's what I thought. But it's now I feel like I missed a lot. I could have started long time ago. So maybe you know whole class it makes me feel a little confident, I would say, in this direction.
Yeah, that is interesting.
The way that you guys teach it.
No, go ahead, Arif.
Yeah. So JC and you are always there to help us. I just bugged you like anybody else. I don't know about others. I bugged you a lot and asking silly questions, and you've been very patient enough to answer all my questions. So that makes me more comfortable, right? So
yeah,
I thought I'm the odd man out. Everybody is having some portion of software knowledge or exposure. The first I really thought, man, I'm in the wrong place. Everybody knows something. Everybody's not understand something. I don't know anything. So that's the feeling I had on the first 2 weeks or 3 weeks. But later, once I get used to your language frequently all over the week, so that really helps. The same type of phrases used, maybe the phrase they used on the first week, I have no idea. Maybe third week, a little bit. Or fourth or fifth week, I understand, right? So that really helps.
That's good. Yeah, one of the things that I've always struggled with pedagogically is, do I show the diagram of what we're going to be doing first? And that's one of the intentional things that I actually don't. And the reason, and maybe it's wrong, but the reason I don't is because I don't want to demoralize. Because we don't actually get to a point of actually seeing that until like the 5th week, right? Whereas if we don't show and we do like quick whiteboard diagrams, because I always will do the quick whiteboard diagrams to at least center a little bit, because otherwise, yeah, it's just not fair, right? You're trying to visualize that's just not realistic. But showing it all, it's quite demoralizing. I've done that before in classes where I'll put for the whole thing first, especially in like the end of the semester, right? That's 10 weeks or 15 weeks. Yeah, and it'll demoralize them. Like, wow, we'll never get there. Like, I don't even understand any of this. Whereas if we take it step by step, right? And yeah, it's a struggle. And yeah, we might lose some people along the way. And I appreciate you guys keeping, sticking around, especially you, Arif. It sounds like, I mean, that's really great that you guys stuck around, because some didn't, right? I mean, we lost some, and we planned on that. We knew it was going to happen, but that's one of those demoralizing things I just want to stay away from, of doing that. And that's also why I give that kind of fluffy presentation, that connected systems IoT presentation, because at least the diagrams are kind of there, right? The 3 things, right? We always go back to those 3 things. It's just at some point we're breaking them down. And now, at the very last day, we can say, all right, here's what we did. In fact, it didn't have everything, because that would be a really complex.
I guess so. Yeah. I had this question even 2 weeks ago. But now when you show this one, it makes all sense, like why you give it at the end of the class. It makes sense. I agree with you.
Okay, that's good. Yeah, and tell me if you would have if everyone would have preferred it all to be up front, also keeping in mind that lens of demoralization too, or just complete like, whoa, geez, what are we going to be doing over the next 12 weeks? Please let us know because that's easy to change, right? That's just showing the same. That's showing the diagram first, but there's so much jargon, and like you said, Ariv, we say things and we're very intentional in how we say things over and over and over because it is a different language. It's a different way of talking, and a different way of approaching things that we don't really want to beat you over the head completely. We want to take it in steps, and we want to make sure that it's consistent all the way through. So that's kind of um, you know that's kind of why we do it that way.
But you showed a diagram the first day, and it was just the three, the embedded system or the cloud, and then the front end and the back end. And I actually, about the 5th week into it, started to get a little frustrated. So I went back to the first lecture, and I had actually started to try and draw the diagram because I had forgotten that you had shown it to us. So then when I could go back and look at the diagram again, I could start putting things in there so it didn't seem as terrifying because it was a relatively simple. I could go back to week 1 and say, okay. Whereas if you had kind of either each week or every other week just brought that diagram out and maybe just put in the pieces that, okay, now we've covered this past week, or now we've covered this, so that by the time you show the whole diagram at the end, it isn't oh, okay, that's how this all fits together. We've been watching it fit together all the way through. But you don't start out with something that's demoralizing or terrifying. You start out with something really simple.
Yeah.
And allow it
to building up the 3 domains and starting to fill the kind of blanks in them probably would have. Yeah, I can see that.
Because as I said, about the 5th week, I started trying to do it myself. Because I thought, okay, I don't see how this fits together. Right. What are all these pieces? They're all coming at me too quickly. And so I thought, okay, well, obviously I don't understand. So that's why I went all the way back to the beginning and started listening all over again. And at that point, I started being able to piece together. And so I've kept going back to that diagram through the whole thing. I have it actually drawn out in my notebook, and I keep going back to it and trying to fill it in for myself, because that's the way that I think. But I think overall, I mean, I thought it was awesome because you guys did a good job. The only thing that might have been helpful, and maybe I just missed it, is if you could have put the homework assignments someplace that actually said.
My problem is I don't actually remember what homework assignments
I know. So you'd throw them.
Off the cuff,
That's right. So you'd throw these things out, and then at some point later you'd say, well, we gave that to you in the homework. And I'm like, oh God, I remember that somewhere. And that's just it. So it would have been helpful just to have some record that said, we expect you to be able to do this.
Okay.
But other than that, I found it, I really appreciated the fact that you kept telling us, go back and watch the videos again, go back. The videos have been a godsend because they really are helpful to go back and listen to and pause and say, I don't understand. Okay, let's go back and listen to that again and watch you code it and then try and work through the exercises ourselves. The other thing I found really helpful is that you posted everything. So we could go back and pull the programs down each week. And if we wanted to say, okay, I'm at week 5, I'm going to take what's at week 4 and try to get to week 5. Then I could go look at week 5 and say, how badly did I screw up from what actually was there?
Right.
And so that for me, those were the things that I found most helpful.
Cool. Thanks. Yeah. The homework was completely off the cuff, and it's almost like a joke. I didn't actually expect you guys to really do the homework, right? But it's more of just like, hey, this could be an interesting thing to look at, and we're not gonna cover it. That's basically what we use that for. But yeah, I probably should have remembered better and put those things. points in the
I
report.
never took you seriously with
Although
homework.
Beth
I
Ann,
just, I mean, I never was going to do the homework. I just thought if at some
oh,
point
I
when
see.
I'm
You just
doing,
wanted. Okay, yeah.
well, no, but if I'm doing the course again, like if I'm going to go back through it, which I am, I want to, it would be helpful to have, you should be able to do this now.
Mhm.
You should be able to extend it this way. And
when
here's
you
an
go back
idea.
through, Beth Ann, pick those out, write them down, and let me know, and I'll put them in the.
I'm going to actually, as I go through them, I will write them down because I actually plan to go through them. I just didn't the first time because
No,
when you're
as
standing,
long as it's only homework, it's okay. If they were graded, I think we would have. At least I would have flunked.
I'd have quit in the second week if this were all graded.
You know, I'm actually glad BJ didn't put it out as a homework, because then I would have come up as a bad student. I'm still at, 6.
Well, that's okay. That's about where I am, so don't worry about it.
I was going to say, I mean, in fact, Ariv, when he was mentioning that he started with zero coding background and how at times he felt demotivated. We should have kind of, did this in the beginning, where we could have also shared that, yeah, we are starting with zero code and we are in sort of same boat, So just to keep up boosting each other,
Mm-hmm.
Oh yeah, that actually helped. In between, I was talking to Arif today also. Somewhere in between, I felt like, oh, I don't think I'll be able to do this. So I think both of us motivated each other, saying,
Yeah.
no, I think, I think we should
We
keep
talked to
going
each
back.
other.
And
I think on the week, yeah, we talked to each other and we shared information. Yeah, that really
and,
helped.
and and actually in every class we when something is going on, I message him asking, are you following it? Then it's like, no, it's all bouncing off. I mean, nothing is.
We had this conversation. Man, I don't understand anything today. Those days were there.
Yep.
That has been the same experience every week. But as everyone have been saying, once you go back to the videos and you kind of repeat it, you start understanding. And I should share, I think it is week 1 or week 2. I really like the approach. When you first introduce the Docker container, you kind of build it from simple Docker file. Then you introduced how to link to Docker files. Then you introduced how now Docker YAML can do it, automate it, link both. Had you done that in the beginning itself, then the whole concept of individual Docker, then how you link it manually, perhaps would not have been clear enough. So while in the first week when you were doing it, absolutely being a zero background in coding, I used to always be, in awe with people if someone says I'm a software engineer. Okay. Yeah, I mean, you guys are totally different now. You're a mechanical design engineer. So I used to be always in awe. So the first week, it was same thing. When you did all this, it was like, I don't know whether I'll be able to, soak it in even later. But watched it quite a few times, and I understand the whole concept why you did it that way. So I really appreciate the approach you guys had building it up. Yeah.
I'll ask you guys this. I don't think that this would work as a live session. Meaning, if we were to basically all be in the same room, classroom style, and not record it, I don't think this would work, right? So this.
No way.
Yeah, this is the only way.
There's too much information coming at you.
And probably that should have also been recorded, even if we are in the classroom.
Yes, recording is a must.
Yeah, I mean, it would be nice to have it in person, but like this, did you find that the fact that it was all remote and we're from all over the world, it didn't really detract from it, or did it? Would it be better one way or another?
As long as I could see the screen, that was the really important part for me. So the difficulty of being like in a classroom is that you really have to have the screen big enough and able to, because I would sit there really close to the the screen sometimes trying to figure out exactly what you were doing. And I actually have two computers, and there are times when I would turn on my Linux computer because I could see it so much better in that, but I had to listen through the Windows computer. So to me, it's no, I don't think it detracted, but you would have to record it, because I agree, 3.5 hours of watching you guys code is about the most intensive thing I have done in terms of learning in a long time. Like, I don't do that to my own students. And I'm like, I'd get off of this and I'd go, it'd take me an hour just to come down, because I would be like, okay, I'm just like so focused on all of this. It's really intense. But that also is, I don't know how, go health. I don't know how else you would do it, because watching you build it, as Sonnet said, piece by piece by piece. Now that we've gone through it long enough, it's possible to look back and say, oh, okay, I get how that piece fit. Oh, okay, I don't need to do that. It doesn't have to be that detailed. I could go and get a tool for, but I at least now know what that looks like. I know what the black box is, so I don't have to be afraid of it.
That's exactly why we do that.
Right. Whereas if you just simply showed us the tool, we'd be like the other people who send us things and say, we can design a website for you, and it's like, you'd think it was still magic, rather than saying, oh yeah, no, I can design my own website, thanks. I
already told a couple of my friends.
Well, I'm impressed with your story, Arif. I think that's awesome, because what you showed us with the stuff that you did on Tuesday, the threading, I thought that's really good, because you demonstrated exactly the thing, which was, I can go and find it on the web. I can go figure this out. I can get it to work. And if you had one day to decide to do that, that's amazing that you feel that confident to do that.
That was really cool, Reeve. That made me feel
really
so good as a educator. That was like, oh, yeah, I must have done something right, or Reeve's just really awesome. One or the other. So.
Or both.
You guys did great. I'm not that awesome. You guys did great.
So JT, did you have something to say? We don't want to cut you off.
No, I was just kind of building on what Beth Ann said about kind of coming down and processing it afterwards. It would take you kind of like that hour just to kind of fully comprehend it and to kind of piece together what you had just seen. And then I think the remote actually helps a lot in terms of the troubleshooting, because you get to see the screen right in front of you. And that doesn't always happen, like at least when I was in the classroom, right, and somebody was having a problem. It wasn't always, you didn't get to see every aspect of the troubleshooting. So I think that was very beneficial, being able to just see all those aspects and working through them.
What do you guys think about the time? Because the last times that we've run this, we've done them really early in the morning, like really early. Like Andy was getting up at like 4 a.m. Pacific time, and it was like Saturday morning too. So it was like trying to get before your Saturday started or whatever. What do you guys think? Do you like the late at night? Do you like would you prefer it during the day? I mean, I know you're working too. So what's the general consensus on that?
First of all, why did you choose Thursday instead of Friday, or what is the strategy behind Thursday?
Why did I choose Thursday?
Actually, there was a polling, right? There was a polling. I mean, I preferred Thursday because I didn't want to waste my weekend, Thursday, somehow you stay up late and then you have 3 more days to catch up with your.
I think that's what it was. It was polling at the time. JC and our Fridays were pretty clear too, so that we knew that from a client perspective, if we took it easy Friday morning, it wouldn't be a big deal. The other thing, the time 8:30 was chosen just because it was kind of out of a hat. It was more like, well, you could do 7. That's a little bit early, like dinner time and stuff. 8:30, like my kids go to bed at 8:30 because they're like 2 and 8 months old, so they're little. So 8:30 was good for me. But then if you go any later, like 9, then you're pushing into the early morning, 1-2 a.m. So that's not a good thing. Then if you try to do it during the day, I mean, we all know we get we're either working or doing other things during the day, so there's just no way. And then really in the morning, I like to do things really early in the morning. I get up real early, like many of you probably do. But there's also that too, is that you feel like your day is done. You're at 9 or 10 a.m. and teaching 4 hours, coding live in front of a group for 3.5 to 4 hours, that is exhausting. I mean, it is like
that actually motivates me. Whenever I feel frustrated, distracted, not paying attention, this is a motivation factor for me. You guys both were with full energy and teaching everything. I'm just simply sleeping, man. This is not fair. You should go and read it.
I that agree, because it is a mental and physical gymnastics. I mean, to do that for 3.5 hours. So if you do that like really in the morning, man, it's like your day. You're at 10 a.m. It's like, man, I'm done today. So,
but I also think if I were trying to do it, I mean, first, I'm not a morning person at the best of times, but if I was trying to do it where I did that, then at 10 o'clock in the morning, I would be like, okay, I just mentally can't deal with anything else that exists today, or at least for the next 2 or 3 hours. Whereas to do it this way, I cheat. I have a nap in the afternoon because it's the only way. I lie down for an hour and I'm like, okay, then I can do this. But then I teach for 3 hours before you do this. So I sit and have to be on for 3 hours to teach. And then I come to do this. So what I find is that 8:30 works well because I've gotten everything done, most stuff done that needs to get done. And then, yeah, it's a hard push through, but at least then I can say, okay, I can do it. I can focus on this for that time frame. Whereas for me, if you had it early in the morning, that would be hard for me just mentally to do it. Mm-hmm. But it's also to try and do a full day's work, that'd be really tough to cope with. Mm-hmm. And this way I can do what Shweta does, which is, okay, I just got to get through Friday and then I've got 3 days.
Okay. Yeah, we considered Friday night, but yeah, it's weekend. Like, no one wants their Friday night. I mean, regardless of, we're all engineers. We're not doing anything Friday night, but we like to think we do, right? So, leave that open.
It's COVID. None of us are doing anything right now.
I considered Saturday night, which was kind of weird, and then Sunday night too. But Sunday night's one of those things that it's kind of like getting ready for the week. So Thursday is kind of where it landed. It seemed like it was okay. So if you guys have any, definitely Slack me or send us an email if you would say, like, I'd much have actually preferred it to be Tuesday night or whatever. What do you guys think of the office hours? I assume those were helpful. A lot of it was just pontificating, kind of stream of thought stuff. But did you feel like it was helpful, or?
Yes, it was really helpful. I wish we could have used it even better, right? And so that's the thing. I wish I learned more and asked more questions and used the office a lot better. But still very, very helpful. Yeah.
Cool. Well, we're still around. Don't worry about asking us questions. We're like this. It doesn't end today. That's the big thing I want to stress. It doesn't end today. I mean, you guys are still like Sona. You're on week 6, so you got 6 more weeks.
Yeah, I was gonna say that.
Don't worry.
Same thing I was gonna ask BJ. I mean, problem with me, I sometimes get myself, lost too much in details. Like, you might laugh. I think I may have spent a couple of weeks actually trying to understand async await. I did a bunch of exercise on my own, only to realize that now I'm behind, what we have what I was able to keep at pace with. So, getting back on the course becomes difficult once you lose that steam. But that's the problem with me. I sometimes get lost in detail, maybe not really necessary at that point of time. But yeah.
And that's the, I see that often with certain personality types that, engineers particularly, but that's a very I describe that as the PhD mentality, right? The ability to, which I sometimes will envy, and that is the ability to focus so much on one specific thing to get to the bottom of it and truly understand it. Like, that's a very consistent kind of thing that I see with my PhD students, and then just kind of what I see in dissertations and things like that. So it's that kind of personality trait. I was never like that. I'm kind of a jack of all trades, master of none. Like I want to get as much information about as many things, but on a surface enough to be able to act like I know a lot about it, right? So I mean that's so I would software is not for those types of people either, too, right? And I think that you found that Sonat is like, sometimes you do have to say, yeah, enough is enough for that. Like, I got to move on. Like, I get the general concept. All right, I don't need to know everything about that.
Exactly.
Software is like that because you'll go down rat holes all the way down to the transistors, if if you will, right? And then you're totally screwed because you'll never get.
What I should share is what I have also realized is you do that, and if you are not able to practice it, especially since we are beginners, then all in that study you have done, it just goes in vain. So better keep up at pace, continue to code it and build that muscle memory, and you will understand it. It's just something I learned from. I mean, I learned from someone else over YouTube that is one way to approach it rather than using your time just trying to understand or
yeah, get to the bottom of something, right?
yeah just get into practice of typing a lot, and it will develop that memory.
Exactly, because you'll get to that understanding. That's the beauty of it, is you just have to give yourself more time. You will get to that understanding eventually, and it's just a different strategy to arrive there, right? So so yeah, definitely.
Yeah, I just slacked something. It is another thing, what it is due to this course. This randomly came on Twitter. I don't follow any software engineer on Twitter, but then this came up and somebody kind of commented saying NPM, not dependency. And I got it, and I said, now I understand it because I attended this boot camp. Otherwise, this yeah.
I really like this one. I gotta.
Oh yeah.
I gotta share this because this is a good one.
Yeah, and that person I think cited one example, and you guys may have experienced it. It seems in 2017 someone pulled off one library from NPM and entire web collapsed or something like that happened.
Yeah. One library, one critical library. I remember that.
Yeah.
Yeah, that everything collapsed. All CI/CD was broken. Everything.
Exactly. Yeah.
One library, and the maintainer stopped or forgot to renew it or something, right? And it took the internet down. But it's truly amazing. Some random kid in Nebraska has been thankfully maintaining since 2003. That is open source software, in a nutshell. But that is, I mean, this is exactly what the deal is.
It turned out that code was 11-line code, and it kind of brought down everything.
It's sad, but yep, that's definitely the case. It's
Key thing being, when I saw that and I read through that, I could understand it, and I was like, glad I understand it just because of this. It would have been completely bounced, as Hari was saying,
I mean, open source is an amazing phenomenon. It really is. Just how much stuff that we use on a daily basis. I mean, the things that we're using right now, Zoom, I mean, is built on half open source. I mean, if not more. I mean, it's just amazing, like the stuff that we all use. All the tools we use through the entire boot camp, which is a fraction, right, of the total community, they're all open source tools. VS Code is open source. I mean, even the IDE that we're using. It's truly amazing the phenomenon that it is. And it truly is a labor of love, right? And hate and sweat and everything that goes into just the frustrations of software development.
There's actually a really interesting book if anybody's curious about some of the history and whatnot, and the theories behind why the whole open source community exists and how it functions and whatnot. It's let's see what year it was written in, but then the name of the book is called The Cathedral and the Bazaar. It was written by a guy named Eric Raymond. I think he's from Mozilla, and it must have been published back either in the late 90s or early 2000s, but you can find it on Amazon for super cheap. Some people even will just only charge you shipping, and they just send it around for free and whatnot. But he goes and he compares the old classic software architecture systems to cathedrals, right? And how they have these tight-knit groups, and then where the open source system is a bazaar, right? You've got this bazaar in which people are going and buying every which thing, and it's this or organization out of chaos that emerges. And he goes and he actually talks about, the motivation behind people and how it's almost he calls it a gift economy, which is really
Mm-hmm.
interesting.
It really is. I mean, it's the reason people do it is for reputation. I mean, that's you build your brand through open source, and the people that have some of the more popular open source projects, they're not hurting for work. It comes, but it's the Nebraska kid that since 2003 that's been maintaining this thing, who's never actually gotten any kind of fanfare or recognition. That happens too. So you got to get lucky too. There's a little bit of the break, right? The Hollywood break that you need. So, but yeah, it's it truly is phenomenal. But cool.
I'm always amazed at just the collaboration that occurs between, I mean, there's like thousands of people that contribute to some of these projects, and the fact that it even builds. Because I'm like, I can barely get 10 people to build software at work. and I can contact each one of them individually, no problem.
Right.
And we can't build software. So
that is an especially interesting point. That how this stuff comes together is still a wonder. But you're right. I mean, how does this stuff come together? It's like we labor over our stuff, and it takes just the frustrations of software development, and then you get these massive open source projects. How did it get to that point? How did you get that many people working on it and get it to this kind of polish? I mean, it's unreal. So yeah, it's an amazing thing. And I hope you guys participate in it too, because it is a gift economy, right? I mean, we have just benefited, just these last 12 weeks we've benefited, just in learning it. Not to mention everything that we've used for years. To contribute back is important, and we do that. I'm always very supportive whenever someone wants to take a little extra time and contribute back to the community. That's a very important thing because we do take a lot, so we should at least give whatever we can back to it. So cool. Well, JC, you want to stop the recording and then they can tear into us, or we can call it a night?